Again, so Leslie, if you want to give a brief intro. All right, great. So some of these questions will kind of seem self-evident if you're in this class. You probably know what R is, and maybe you want to know why you want to do it. So I'm going to give a brief rundown of what R is. So it's a language and environment for statistical computing and graphics. That's how, in a lot of respects, it started. It's kind of like a pipelining software as well. So it's kind of grown in the last 15 to 20 years, really with a big boom in the last like 5 to 6. So a lot of it was about statistical computing, but there's packages for kind of all different types of things, like natural language processing, the whole gamut. So it's an open source implementation of this thing called S, right? So this was built before the time of Google. Otherwise, you'd probably make a language that was a little bit more Googleable than R. But we will talk about how to maybe Google for some answers. But it was written on S. It was developed at Bell. So it's open source and open development, which means there's a community of people who some it's their job, some of them they volunteer, and they write all the code that kind of goes into the thing that you get when you download R, right? So all the base functionality and all that kind of stuff. So some of the reasons why a lot of people like to use R, it's powerful and flexible, so it can do a lot of things, right? That being said, some of that flexibility comes at a cost. In the sense, SAS is developed by an organization, Stata is developed by an organization. They do a lot of work, a lot of time, a lot of energy, a lot of money to standardize those things. So that, function A and function B have relatively similar syntax. R, I write a package, the next person writes a package, the next person writes a package, and we'll talk exactly about what packages are. Those syntax might be completely different. I might have a very different way of organizing my thoughts and code and functions than the next person. So it is flexible, it is powerful, but for example, that does come at a cost. So it's free, right? You can download it on your laptops, no licensing. Really where the power comes in is these add-on packages or these add-on software that is written by the community. So there's now over, I believe, 12,000 packages out there between the Comprehensive R Network, CRAN, where you downloaded R, and Bioconductor, which is a bioinformatics repository. So a lot of it was designed for statistical computing. So there are a lot of state-of-the-art statistical methods, a lot of mixed effects models, that kind of thing, penalized methods. Kind of you name it. It's a high-level language, so there are things that are highly technical about it. It is an object-oriented programming language of sorts, so that you can do certain things with objects that you wouldn't be able to do in SAS or Stata, for example. So in SAS or Stata, saving out a table as an object and being able to manipulate that. For example, in Stata, you have to save it maybe as a CSV and then reread it in, or use postfile or some of these other functions to kind of not hack your way into it, but it's not necessarily designed for that. If you've used Stata before, getting out regression tables and stuff like that is kind of a chore. That is not a big of a chore in R because you save that table out, you can change the column, change the rows, just like you would any data set. And SAS is a totally different kind of beast altogether. It does a lot of good reporting, but getting things to manipulate the way exactly you want them is not always the easiest set of code. So why not R? So as you can see by the number of people here, which has been growing in the number of years us teaching this class, there's a fairly steep learning curve. There are a lot of resources online, but I think a lot of new users, I've heard the concern, where to start, right? And there's not like a manual, or if it is, it's sometimes too technical or too specific. So that's why we kind of built this course. It is programming oriented and it has a minimal interface. So when you download R, it's just a console, right? There's no point and click. There's no drop-down menus like there is in Stata or some other pieces of software. So to a lot of new users, that's kind of a non-starter. The other thing is, the core R members are not a company, right? They're not necessarily all paid to do this. So there's not a lot of centralized support. So you rely on Stack Overflow, online communities, R Help, and other listservs to kind of get answers. But there's no guarantee you're going to get that in a timely manner or necessarily in the most polite way. So that does throw some new users off, and that they don't want to do that. Sometimes it is annoying to update, so if they make major changes to the versions, most things will still work, but that's the beauty and the curse of working with a actively developed language, is that your code from 10 years ago might not work, whereas SAS puts hours and thousands of dollars to say, your stuff today will work on a computer from 1996 using SAS 2.5, right? So it's slower and more memory intensive than more traditional programming languages like C, Python. A lot of packages in the advent of the last 5 years have really tried to bridge that gap. So there are some things that really speed up code, but it's if you're saying, if you were a software developer and you wanted to roll this out to like an app, might not be the fastest thing. So really quickly, we try to bridge this a little. We were talking about the force plot. So, why are you here? I want to kind of get a gauge on why. Learning R is good, but there are other languages, there are other reasons. So do you have any? Yeah.
I'm actually a pharmacist, and I'm doing a postdoc fellowship at the FDA. And my research project is mainly dealing with like meta-analysis type work with R programming. So that's why I'm here. I haven't been introduced to this. My only statistical software that I used in pharmacy school was SPSS.
Yep. Yeah. And so SPSS, right, has drop down, is more or less built to be drop down kind of only. So I know it's free, but there's other responses I get where it's like, somebody in my lab used it and I have to take over their code. So,
So in 2000, we were here and they changed us in Stata.
Mm-hmm.
And the thing that irritates me the most about Stata is the vast number of intermediate files that need to be saved down on my drive when you're manipulating data sets and merging. And it just clogs up. And it's just really inefficient to code. And the second thing is figures are not as beautiful.
Yes. Plotting is a big thing, and if you've worked with Stata and getting a figure to look exactly the way you want, you can spend months in some respects, right? So I will say that I'll show a lot of figures in this. Making a publishable figure takes a lot of time, takes a lot of energy, takes a lot of customization. So accepting defaults is never something we're going to condone here, but we will show you the way to customize it. But still figures I write for papers, even though I've been programming in R for almost a decade. It takes me probably an hour or two to customize them exactly the way I want, with the resolution, with the font sizes and all that kind of stuff. So I just want to kind of put that out there.
After 37 years with SAS, I decided I wanted to learn R because people are using it and being able to communicate.
Yeah, that's a good point.
So I'm an assistant professor in neurology and psychology.
Mm-hmm.
So we mostly use SAS and SPSS, but we've been doing more interesting things that were just required more complex data visualization techniques, and a lot of us are starting to learn R for those reasons.
Yeah. So we will touch on ggplot for plotting, and there is some other interesting packages out there called Plotly, which if you have a plot that's already kind of made and you want to make it interactive, there's a relatively easy way to do that. Also, we will touch on it. We will not talk about Shiny, which is a system in R that allows you to write R code and essentially have a web application that can be interactive with the user. So you can say, what do you want to do? Can you click some checkboxes and stuff like that? Send that information over to R. It can run an analysis and plot a figure back just based on a web page where no one has to actually write any code. Okay, so I'm going to upload and update materials hopefully throughout the course. That shouldn't be too frequent, but if somebody does find an error or something like that, I'll try to upload it. So if you do download like the static PDFs, they might not be necessarily the most up-to-date, but if you go off the website, it should be the most up-to-date things. All of the materials for this course are, I will share them at the end of it. I'm not sharing them now because there are answer keys and stuff like that we don't want you to have until kind of after you do the labs. So there is a website where you can download literally everything from start to finish that made this course. And it's almost all written in R. Okay, so really briefly, we're going to talk about RStudio. So when you start with R, say, I downloaded R, this is usually what you get. So I'm going to open the R application. Something like this. Beautiful, right? Just beautiful, just so intuitive. No, it's pretty much a console that you type commands in. It's got some other buttons, and it's got some menu items. There are some reasons why we don't necessarily just work off this, and that's why we use RStudio. We will talk about exactly why we use RStudio in the next slides, but at its very core, R is just a console. R is just a line or a place where you type in commands. And whether you type in the commands interactively or you say run this whole script of commands, that's what R is, right? Just a command line interpreter. It's a calculator. You can create variables or objects, and we're going to talk about exactly what those are. Kind of like what I was talking about before when I said, R can hold a table, or R can hold like a graph as an object, and you can manipulate those things. That's what I'll be talking about, creating variables, which is not as intuitive if you're coming from other languages with respect to statistics. And it applies functions. So you say, I want to apply this function to this data set, or this vector, or this column. And so throughout the time, I will be saying variables in the sense of things that are in R. Right? I don't mean a variable in a data set. Right? That being said, sometimes I will slip in and say this variable in this data set, right? Because that is kind of the way it's usually termed in statistics, independent, dependent variables. But most of the times I'll try to say column of a data set or column of a data frame, and we'll talk about those in a minute. But whenever I say variable, usually I'm talking about something loaded into your memory in your computer. And we'll get into these specifics. So in RStudio, there's an analysis script, which allows for interactive visual exploration. So let's go to that really quickly. Sorry, it should be... So these got a little turned around, my fault. So this is what I wanted to show you. So this is the console. So this is RStudio. Okay, so if you've downloaded RStudio, you open up your RStudio. This is the console. So when I open that R application, this is the exact same thing, just put in here. Okay, and the analysis scripts are put up here. So I usually don't. Okay. So R revolves around functions, right? Just a set of commands that execute a script of code, right? To do something, right? Whether you want to sort a column, you want to make a new variable, you want to run a model, something like that. So that's pretty much what we're talking about, functions. So it's just commands that take input, do something, return an output. So when you download R, it has a base set of functions, right? So when you load up that R application that I showed you, it's got a couple functions already loaded, like LM for linear models, GLM for generalized linear models, sort to sort something, things like that. That's what we're going to be referring to as base R. So that is the thing that the R organization maintains, writes, and says this is what R is. That's important because when we start using other people's packages, we are going to differentiate between what is base R, what is the base that you just downloaded, and what are kind of add-on packages. And I'm going to do that because the code online that you say, like if you put a help file out there and say, I want to know how to do this, sometimes they're going to give you ways to do it with additional packages. And sometimes they're going to say, well, if you don't have all these additional packages, you can do it this way in base R. So the other thing you will note, there are many ways to kind of skin a cat in R. Right? There's many ways to do the same operation. Some are more efficient than others. Some are more intuitive than others. But there are 5 to 10 different ways to do the exact same operation with more intuitive code or not. We're going to try to give you the code that's kind of the most intuitive in my opinion. So, like I said, other people write these packages. I would like to think some of my packages are good. Some of them are not. Some of them I wrote 6 or 7 years ago. I don't know if that code still works as well as it should. It could have been optimized, something like that. So, all I'm saying is, if you are going to use packages from other people, we're going to try to talk about very briefly how to trust those things. Right? So the way they're described is R extensions. So again, you need to know base R because answers from Google will use that. But there have been more intuitive ways developed in the last probably, I would say, 5 years to say, hey, this is how you can manipulate this data set in a way that's like, oh, that code makes sense. Whereas if you do it in the standard way in R, the way I would say I grew up on R about 9 years ago, to a new user, it's not intuitive. So Hadley Wickham is kind of an R guru out there. So he wrote ggplot2, a package we'll be talking about extensively for visualization. He wrote a package called dplyr, which we'll be using for data manipulation, and a whole bunch of other packages that have been deemed kind of the Hadleyverse of packages. So he has a lot of packages that are very, very ingrained into how we're going to teach this class. They've redubbed it to be called the Tidyverse, so they didn't have his name attached to it. But the reason I bring him up is that I trust almost every package he puts out. So unless he says, this is a package I wrote yesterday, don't trust it, it's a very reputable source. And he works at a company called RStudio. So there's a company called RStudio that makes a piece of software called RStudio. Okay, so the thing you downloaded is RStudio by RStudio. Okay, so there's a pretty interesting blog post here. One of our faculty, Jeff Leake, wrote saying, how do I trust an R package? So generally, some of the strategies are look at the popularity of the package. If only 3 people have ever used it, you don't necessarily think that it's been well tested, right? At least by the community. That being said, sometimes if you're looking for a very specific analysis or a very specific function, sometimes you have to use that. But for the most part, for 95% of the things you want to do, make box plots, make histograms, do all the kind of visualizations that you want, or data manipulations, or generalized linear models, mixed effects models, that kind of stuff. All those are are very popular packages that have been extensively tested. And a lot of them that are done for modeling, like mixed effects models, GEEs, that kind of stuff, have been validated against some of the other standard pieces of software in SAS and Stata, for example. Okay. So whenever I talk about RStudio for the rest of the course, I'm not talking about the company. I'm talking about the piece of software on the computer, which is described as an IDE, right? So an integrated development environment. So really the reason we use RStudio, it makes it easier for the user, right? Just typing commands into a console is not intuitive for a new user. Being able to search for commands, have everything in one cohesive place is really what RStudio allows you to do. What it is not a drop-down of statistical tools like in Stata. So in Stata, you can click a drop-down menu and say, I want to do a longitudinal data analysis, set up my data, this is my Y variable, these are my X variables, and it'll set it up for you. That is not what RStudio is. And in general, in the R community, there's not really anything out there like that in the same way. There are 2 packages that we point to, we're not going to talk about them, R Commander and Radiant. So if you click on those, it'll show you some tutorials. They have kind of things that'll say, I want to do a histogram or I want to do a Fisher's exact test, and it'll have some drop-down boxes, but we'll cover all those commands here. Okay, so some of the things when I say it makes it easier. So syntax highlighting. So sometimes you want to read in a data set, and so we're going to have a function that reads it, and then we're going to pass in the location of that file. Right? And that location of that file has to be, for example, encapsulated in quotes. Say this is a string. This is where the location is. But let's say you forgot a quote. Right? With syntax highlighting, the rest of your code will change a different color to more or less indicate that this you're more or less missing a quote. Right? So things that you common mistakes, common typos, and stuff like that are really helpful to be caught with RStudio. Code completion. So let's say we're using a function, and it takes in an x and a y and a z. But let's say, so 3 variables. But let's say the arguments in that function aren't named x, y, and z. There's something really long or strange. If you hit tab, it'll say, hey, these are the arguments of that function, just so you don't have to remember. So there's just intuitive ways to kind of allow a new user to get up and running, or just any user. And smart indentation. So a lot of times when you're writing code for the first time, or writing code in a new language, it's really messy. It's not formatted well. It's really hard to see. The RStudio really helps you do that. And it easily allows you to manipulate and jump between multiple projects and working directories. So if you have 2 RStudio windows open, one can be an analysis from collaborator A, another can be an analysis from collaborator B. There's no crosstalk between them. You can kind of separate them out and say, oh, I want to just run this and let this run for a while and switch over to another project. That's totally fine. Okay, so it also tells you what's loaded up in your memory. It shows you the history of your plots. You can scroll through them. It allows you to export PDFs and figures using point and click. We're going to show you how to export them and save them from the command line. It has help and documentation kind of all in the same window, and it shows you all the search history, all the commands that you wrote in the last, 200 or 300 commands. So again, this is the console. This is where you type things, more or less, if you want to do things interactively. So say, I want to run this command, I want to read this data set. So it's where code is actually executed. You can type in here for things interactively, but once you got a piece of code that you want to save, you don't just leave it in there. You put it into a script. Okay? By the way, so whenever I'm doing so let me pull up my RStudio really quickly to show you what I mean. So my RStudio looks like this. So I use a black background, white things, stuff, white text, that kind of stuff. So my RStudio isn't necessarily going to look like yours all the time. That's just because I changed some preferences around. Okay? So if you're saying, why does his look like this and mine doesn't look like that? It's because I've changed the preferences. And so if you go to RStudio, preferences, pane layout, it'll put the panes in one of the four corners that you want. So for example, source will be here, console will be over here. So I like my code on my left, where I'm executing it on my right. That just intuitively makes sense to me. Let me just jump back. The way RStudio by default has it, code's up here, where you execute it's on the bottom. That doesn't make sense in my brain, so I've changed it. And then also you can click appearance. So if you don't like white backgrounds and dark text, then you can change all that kind of stuff. And again, we're not talking anything about R yet. It's just kind of getting set up and running. So here, let's say I've been writing all my commands in here. I finally have some commands I really want. I'm going to put them in a script up here. So you'll see by default they'll all be called untitled. And when you edit anything in here, this name up here will change to something red and have an asterisk to indicate that that hasn't been saved yet. So source. So if you double click on an R function, or sorry, an R file on your computer, and RStudio is associated with it, that's where they open up to. Right? It's where the code and the comments are. You can highlight code and press Command Enter or Control Enter, Windows or Mac, to run the code. So that's where you will actually save analyses. You'll do the interactive stuff in the console, but you'll save all the commands somewhere else so that you have a reproducible analysis in a script. So over here is the workspace / environment, right? So it'll say environment is empty if you've started things up. But once you start loading in data sets, loading in tables or making models or something like that, this is where it's going to list out everything that's loaded in your R session. All the things you've created. So it tells you what objects are in R. Again, I'm going to say objects or variables. So things you defined, things you've created. This could be a data set, this could be a model, this could be a whole bunch of different things. So history, I'm going to go back. So history is on the other tab. It'll say, show me the previous commands. It's good for, to look at for debugging, but don't rely on it as a script, right? So you can actually copy and paste those into a script, but sometimes, depending on how you open RStudio and all that kind of stuff, if you open that in a different directory, it might not have saved all the commands from your previous session. So it's not good to rely on and say, oh, well, everything's saved here. I don't need to save a script. So you can also type the up key. So if I'm in an RStudio session, say x equals 5, I'm going to make this a lot bigger. Right? I say x equals 5, y equals 4. If I just hit up, sorry, let me, if I hit up, it'll scroll through the previous commands that I've run. So instead of going to history, which says, x equals 5, y equals 4, sorry, this is a little low for most people. Pull that up. Right, instead of having to go over here and look through that, you can just hit the up button and it'll scroll through your previous commands. So there's other panes that we don't really talk about too much because we don't use them as frequently. So files, shows the files on your computer in the directory you're working in. So sometimes if you're in a certain folder, it'll just list the files in that folder just to say, for example, if you ran a piece of code that says read in this data set, and it says that data set's not there, you can double check the, for example, the if it was a typo in the name or something like that from the file. Viewer, I will try to use this a bit more. So those who use Stata or SAS, for example, do a lot more interactive browsing. So I believe, right? So you actually look at it like it's a spreadsheet. And RStudio allows you to do that. It allows you to view like data sets like that. I don't do that so much. We're going to talk about two commands, head and tail, that pretty much just print out like the first 5 rows just to get a gist of what's going on. That's what we use generally. By we, I meant myself and Andrew, the other creator of the course. But we will talk about the viewer and how you can kind of scroll through things if that's more intuitive to you. Help, we're going to go into that. It shows the help of our commands, what the arguments are, what are the things you're supposed to be passing in, and so on. Plots, all the plots you've done. Packages is a list of R packages that are loaded up when you're running R. So there's some other shortcuts. Again, Command Enter will execute the code. Let me show you that in a minute. Control 1 takes you to the script page. Control 2 can flip around the console. There's a whole bunch of different shortcuts. But what I'm talking about here is if I say x equals 5, if I hit Command Enter, it'll, instead of having to copy and paste over and over again, right, I just highlight these 2 lines and hit Command Enter. Or if I hit Command Enter, it will, Command Enter, it will execute the line and then move the selector down a line, right? So let me just demonstrate that one more time. I'm here, I hit Command Enter. This is going to move down, execute, and move down, so that you can kind of step by step go through your script to see if something went wrong, or you step by step and say, okay, this is what the data set looks like here. There's 15 rows or something like that, and then you did some merging operation and there was no data there for some reason. So you can see like if a merge didn't go right or something like that. Okay, so haven't talked about any R syntax, any R, anything like that, and so that's what we're going to get into now. So this is objects in R. All right. So again, everything right now is built. Is really just going over setup. The reason we did go through this is in previous years we made more or less a slide that corresponded to every single kind of question we ever got from this course about like what's going on. So for example, we made that slide, to show you how to make the layout differently because some students were a little caught up that our RStudio didn't look like their RStudio. So we were trying to head off any questions and get everybody kind of set up on the same page. So does everyone have R and RStudio downloaded and kind of up? Okay. All right. So let's start talking about some code. So the other thing is, downloading that and getting that set up is relatively easy. But if you don't necessarily update your software, sometimes different versions of the software, let's say you had downloaded R 5 or 6 years ago, and then you try to run something that someone else, developed, say, oh, it didn't work. And that could be because, for example, if I updated my R, they might have added 1 or 2 new functions to the very base of R. And that might not work if you used your version from 5 or 6 years ago. So that can be sometimes a frustration. The recommended thing is to update whenever there is a major or minor release. So for example, everyone here should have R version 3.4.0 on their machines. Yeah.
I had problems when it had an update because I had a version of R from last fall and it wasn't quite up to what you recommended. I could not, when I went to that website, I couldn't figure out, it said something about for first time installation. And I couldn't, so I ended up just uninstalling it, installing the new version. There must be a way to.
Yes, there are. So, for example, I probably have like 100 packages loaded in my, downloaded onto my machine. So there are ways to kind of update that. But when they do a major release, so the version, so it's 3.4. So the 3 is major. So if you had like 2.5 or something, and they made a very major release, it's not so easy to do that. But we can do that. We can get you up to date, kind of after.
Well, no, I mean,
Oh, you are up to date.
I
So you just.
installed, but I just.
Yes.
For future reference, there must be a way to.
There are, yeah. So we can maybe touch on that a little later. So sometimes data type problems. So depending on how you read in a data set, one column you think is all numbers, right? But let's say it's an Excel spreadsheet and you read it in, and there are spaces in there, right? Rather than but when you look at it, it looks like an empty cell. When you read it in R, if you haven't specified that empty spaces or just empty cells, it will then say that whole column is, for example, characters, right? It's not numbers. So let's say you had age, but one cell happened to have just a space in there. It's going to read that whole column in as a character, which is sometimes frustrating. So we're going to talk about data types and what you can do, because then you can't do things like do the age plus 5, right? You can't do that because R doesn't know how to add a word to 5. So sometimes we're going to allow show you how to identify, what's a character, what's a number. So for example, in Stata, if you open up the browser, they're different colors. Strings are red, numbers are black, label things are blue. They're not color coded in R, but there are ways to kind of differentiate, and there's functions to say is this a character or not? So working directory problems. So sometimes you say, I want to read in a file, and you put a file name in there. So one, that is usually case sensitive. So if you had a capital A versus a lowercase a, it has to be the exact file name. The second thing is a lot of times new users will put in a complete file path, right? So it would be C drive / user / John Michelli / document / R class / file name. And if I gave that piece of code to you, that's not going to run because you don't have that whole path, right? Unless you use my name for your login for some reason, okay? So RStudio can help. So RStudio projects, which we'll talk about a little bit later, will open you to the directory of that project. So what I'm talking about right here. So when I go to the console, it'll tell me what working directory I'm in there. Right, so it says I'm in my Dropbox teaching intro to R. And so if I go to read in a file, let's say the Baltimore City employee survey, and I wanted to read the CSV in there, right? I use a relative path, right? I don't put C drive, all that kind of stuff in the beginning. I'm just saying I want to read in data and this file name, and R says, okay, you want to read in this file? I'm going to assume it's in this directory. Well, it's actually in the data subdirectory, but because I put a slash, it's in data, right? Data /, so it means it's a subdirectory. So if I did go to files and I went to data, we see that is in there. And so very briefly, I went over this very quickly, but when I click data, I hit the tab button, and it'll say, these are the files in there. Right, so if I open something with a quote and said date, some folder or something like that, I can scroll through and then get the exact name, hit enter, and so that I know 100% that this file name is going to be correctly, there's not going to be capital letters, lowercase letters, errors, and that kind of stuff. Yes?
How does R differentiate that data is a variable and not a piece of string?
Here, inside, quotes. So let's say, file name is an object in R, and so these run the exact same pieces of code. The only thing at the top, I put quotes around it to say, hey, this is a string. Whereas I didn't, I passed an actual object into the function, and it wasn't quoted, so R says, hey, let me look in my environment, and I'm going to look for the thing that's named file name. It looks, finds it here, and then essentially passes in this string. Does that make sense? So the way it differentiates, at least here, is it's quoted. Single or double quoted. R interprets that as a character, as a string, as a word, rather than some sort of object.
But isn't data a variable or something?
No, sorry, that's just that's just a folder in my directory.
Oh.
Yeah, so I have a folder called data. Sorry about that. Yeah, so.
It was like a reference to.
No. So yeah, so it's no. Good question. All right. So we're going to talk about that a little bit more in the input-output lecture for data input. So R is case sensitive. Lowercase x, uppercase x are totally different, right? Lowercase x in the just example I just did live was a data set that I just read in. I could say capital X equals 4. They're totally different things. They're not linked in any way. This is another thing coming from other languages, which is a big kind of a concern, because you can have 2 columns, age and age, one with a capital letter, one with a lowercase letter, and you can have them both as columns in your data sets. Whereas other software, that's not always the case. So it's just case sensitive. Our studio does help with tab completion. So let's say, for example, you like to make really long variable names. So and what I mean by that is this is a variable, John. Okay. Note a few things. Make this a little bit bigger. 1, you can put underscores in there. 2, you can put periods. So underscores and periods. There are some other rules. You can't start with. You can put numbers in there. But if you start typing in our studio, you'll say, hey, what's in memory? And it'll show you what is in memory if you have some like unique starting string. So you're saying this, and I say underscore is, and then I hit tab, and then it'll complete it for me, right? So this is really important, especially when you read in data sets that you haven't necessarily curated or have really, really long variable names, especially when you're reading, for example, from Excel. So sometimes people like to write more or less a column header to be an entire sentence, right? So sometimes this is a good way to allow you to still be able to manipulate those variables. We are going to talk about how to rename those columns, but you can use tab completion in an effective way so that you don't have to remember exactly the way it's spelled or the case. All right. So you should have latest version of R. So we're going to open our studio. So you could do files, new, and R script, and we're going to save the blank R script to a directory, and we're going to add a comment header. Okay, so this is an example of a comment header. So you'll note that every single line or somewhere in the line there is a hashtag or a pound sign. That tells R this is a comment. Okay, so you can have as many as you want. So we're just doing it so we can, visually see that this is a group. We put a title, an author, a purpose, for example. Say this is a demo R script. I wrote it, and what's the point? So this is usually useful for later in life when you come back and say, what was this thing supposed to do? It at least gives you an overall kind of message as to what this script's supposed to do. So if you put a pound sign at the beginning of a line, everything after it's interpreted as a comment. You can have again, pounds within a comment, right? It still just says this starts it, everything else. I'm not going to interpret this as code. This isn't our code. It's just comments. You can write text. You can put quotes. You can do indentation, whatever you want. So again, when I was talking about before, so this is a comment, and I can save that. I'm gonna copy and paste that comment header. I'm going to copy it at the top, and then I'm going to save it, for example, to my desktop, day1.r. And if I highlight everything and hit Command Enter, it'll run everything, but none of this stuff is interpreted as code. And then also, if you have code, and then you have, pull this up again, and then you have a comment afterwards, that's still okay. So it says, this is code, pound symbol, don't interpret anything after that. There is no operator for multi-line comments, right? So that you don't have a thing where you say like, this is a comment, or start a comment, I can write all the text I want and end the comment. That's not how it works in R. You have to put a pound sign in front of everything. But if I like to write a bunch of stuff, you can highlight, and Command-Shift-C is the shortcut, but you can go to code and comment uncomment lines, and that'll comment all of them out for you, right? So there is no thing. So for example, in Stata, you say \star, star \, and everything inside of that will be interpreted as a comment. That's not how it works in R. You have to comment every single line out that you want. But again, you can use a keyboard shortcut or RStudio to highlight as many pieces of code as you want. All right. So in the slides, we're going to talk about code or code chunks. So it's a shame because projectors don't really like to differentiate the colors on this. But if you have these slides open on your machine, this should have a little gray box around it. Okay. So if you look at that, it'll have like a gray box all the way out here, and that shows you in the slides that is code that we've run. So the way it's set up is this is the code. It'll have a gray box around it. It'll also have some highlighting, and then afterwards is the output of that code, usually. So in this case, we just printed the string I'm code, and this is the output from R. Okay. So that's kind of how you read these things. And we will have code interspersed throughout. There should be, and for every single lecture, you don't have to be copying and pasting. There should be an R file on the website that has all the commands that we've executed in this thing. So if you do go to the website, for example, and we're in basic R, if you click the R, this is all the code that's run, right? So print code is there. I'll make this a little bigger. Print code is there. So if you want to follow along and execute these things on your own, download the R file, open that up in RStudio, and you can go that way. Yes?
Do we need to download RStudio separately from?
Yes. Yes. Totally separate. Okay. All right. So again, R is just a calculator, right? So if you type in, so it's just executing commands. So you can do all the things that you want to do with arithmetic. So addition, multiplication, subtraction, powers, right? So the caret is the power operator in R. You can also use 2 asterisks back to back. If you did 2 asterisk 4, that is the same as 2 to the 4th power. But usually most people use the caret. Also note that by default, unless you tell R you don't want to necessarily see the result, it's going to print it right out. Right, so it'll print to your console. That's not a huge deal most of the time, but sometimes the output that you're just trying to, do some manipulation, see what's going on, and it could be a huge data set, so you don't always want it to print it out. You usually want to save it to an object and then maybe view it, and then you can just trash that object later. Okay, again, caret, double stars, power, it'll work just as a calculator. You do all kind of operations in there, matrix multiplications, that kind of stuff, modulus, but also it really it keeps the order of operations, right? So I don't know what moniker you use. We used when I was a kid. Please excuse my dear Aunt Sally. So parentheses, exponents, so on and so forth. Multiplication, division, subtraction, addition, right? But parentheses, you can group things together. And so if you want things, if it's x plus 5, so this will execute 2 times 3, right? Get 6 squared, get 36, add to 2. All right, so if you want to 1 plus 3 divided by 2 plus 45. Again, this is not 4 divided by 47, right? This is 1 plus 3 is 4 divided by 2, 2 plus 47. So just if you want to group things together, just do the order operations with parentheses. Okay. So what are we going to get? What are we going to get for the first one? Gotta do some fractions. All right. So we're going to get 6 quarters minus 3. So negative 1.5, add 2, should get 0.5. All right. Let's just make sure I still know how to do arithmetic. All right. Did I say negative? Yeah. Positive. All right. So again, you just play around with that. So a lot of times you won't be doing things as simple as this. You'll be multiplying 2, vectors together, or age squared, or some column name, or something like that. But all the same concepts still work. The only difference is instead of using numbers here, you're going to be using variable names of variables in memory, or you're going to be using column names of a data set and so forth. All right. So now, how do you create a variable? How did you assign it? So I gave you a little preview when I was doing things interactively. So the way you create something in R, or the way I'll describe it, is assignment. So there are two assignment operators. One, I'll call the arrow, but really I call it the assignment operator, or the equal sign, single equals. So if you say x equals 2, now in your workspace, there'll be a variable called x. It'll have the value 2. Okay? So throughout the entire course, we will be using equals. That being said, we show you the assignment operator because sometimes that's more intuitive to some people, right? It's a one-way operation, right? You're saying I want to put 2 into x, right? Because you cannot do this. You can say x equals 2, but you cannot say 2 equals x. It's not the same thing. The left-hand side is always the thing being assigned. Okay? So whatever object you want to create is always on the left-hand side. So a lot of the code is in most of the help in R, in like Stack Overflow or any of the websites you really look for help, they will use one of the two, right? So answer 1 might use the assignment operator, answer 2 might use the equal sign. So we want to let you know this exists, but we're not going to use it. It's still very, very common. I don't use that because you have to use, you have to do 2 things. You have to press 2 separate buttons versus 1. So if we say x equals 2, now we can just print x. Again, we're just going to get 2 back. And like we did with other operations with arithmetic, x times 4 is just going to be the exact same thing as 2 times 4, x plus 2. It's going to be equal to 4. So there are many, many, many different classes that we're going to talk about. The most common one that we're going to talk about with respect to data is called a data frame. Okay? You can think of it as essentially an Excel spreadsheet. It's a type of object that has rows and columns can be different things. Column 1 can be age, column 2 can be gender, column 3 can be some ID variable, right? Just set that all the rows have to have a definition for all those variables. It still can be missing, but it has rows and columns. It's essentially a rectangular object that has some column names, maybe some row names, and some data inside them. So they're a little advanced in the sense the way you access columns and rows and stuff like that. So we're going to step back and start from the ground up. So we're going to be talking about one-dimensional classes, two-dimensional classes, and then some more complex classes. So you start from the beginning. We're going to introduce one-dimensional classes, which are also called vectors, right? So vectors can have multiple sets of observation, but each observation has to be of the same class. And class, I mean, when I say class equals x, class of x, so this is a function, class. Before, again, we set it to be 2. X is 2. If I say class of x, it's going to say numeric. So more or less anything that holds a number in R is a numeric class, right? I mean, and I'm talking about when you're thinking about Excel spreadsheets, one column of your data, let's say age, that is a numeric column, okay? We can assign y to be this string, and again, we tell it's a string because we quote. Again, we can use single or double quotes. We really try, I think throughout the course, I use double quotes for almost everything, but if single quotes make more sense, have at it with single quotes. We say hello world, we print it out, and we say the class of y, and y is a character. So this is a little, the bottom of the screen is a little hard to see for some, so I hope we can bring that up. So it's a character. So the other thing I want to note, let me just go back to full screen. Y is a character, x is a numeric. When I printed x, it's had a bracket, just had the number 2. When I print y, it's got quotes around it. So if you print something out and you see it's in quotes, you should know that's a character, just by the way it's printed, not having to use the class function at all. Because when R says, I'm printing out numbers, I'm not putting quotes around it. When I print out characters, I'm going to put quotes around it so people know that it's a character. We're going to talk about another format that is much more intuitive for categorical variables in a little bit called factors. But this, R just sees this as a string. You can do string manipulation, all that kind of stuff. Okay, so let's try assigning your full name to an R variable called name, right? So it only has really 3 components, right? I'm gonna do it up here. Name, quotes, equal sign. So my name is John Michelli. Okay, so we go to the next slide. Not surprisingly, we already have that out there. If you just type it again, by default, it's just gonna print it. We see my name in quotes. Okay. Note, those things are still called vectors. They only have one element, but they're still called vectors, right? So a vector can be of length 1, it can have one element, it can have multiple elements, it can have 100 million elements, it doesn't matter. But whether it's 1 or 100, it's still called a vector. That's not, so some people, at least if you've taken some math classes over the years, they say like a one-dimensional thing's a scalar, a bunch of them is called a vector. No. Anything that contains a string, or sorry, not a string, a set of things that are all of the same class, we're going to call as a vector. So, a lot of times, it's great to have one thing, but usually you want to have more of them collected together. So the way you do that, the way you create a vector of multiple elements is the C function. So the combine or concatenate or collect function. So that's how you create a vector in R. So it's most usually used for creating vectors of numbers, character strings, and other data types. So here, although I'm gonna just show you. I think I'm 100% sure that we don't use the assignment operator throughout, but right here we do. So we say X is assigned this vector of 4 numbers, 1, 4, 6, and 8. So again, X is assigned C, and then we just start typing in the elements that we want to fill that vector with, separated by commas. Okay? So C is a function. We print it out. It just prints it back out. Again, it doesn't have quotes. It's a number. We say class. It's still a numeric. All right, does that make sense? So the C function, you'll use that all the time. Okay? C is important. C is useful. Luckily, it's very short, right? Just C. But it collects things together. So let's assign, so I'm going to assign my first and last name as 2 separate character strings into a single vector called name2. So, right, we're going to use the C to collect things together. We're going to separate things by commas, and we're going to put quotes around things because they're characters. So name2 is equal to, we're going to collect John and Michelle. And now this is a vector of length 2, right, or a 2-length vector. Okay? So again, we see it printed out. It prints out John, it prints out Michelle, and it puts it in quotes because they're characters. But again, we'll talk about why this 1 is there in a little bit. So it's just as a reference to show you like the index of the vector. So if you printed out things with 500 elements or something like that, and you want to say, where's that element? Is it element 5 or 100 or something like that? That's just an indicator saying, that's where it is. So let me actually print out like 100 things. So it doesn't always just say 1. So for example, it says this is the 41st element and stuff like that. So these numbers in brackets in all the code that we've shown, right? It just says 1 over and over again. That is just it doesn't have anything to do with the data. It's just a way R prints it out so that if you want to say, where is this element, this allows you to kind of figure that out. We're gonna show you how to do that programmatically, but that's just why you see this little bracket 1. So now you got a vector. We can ask how long is it? How many elements does it have? So we're going to use the length function. So again, x we assign to 1, 4, 6, and 8. Say length of x, we're going to get 4. Okay? So if you wanted to say, if you had a row of ages or a column of ages, you would say how many elements do we have there? We could use length. Again, if we set y to be hello world. Length of y asks how many elements are in this vector, and it gives us 1. That does not count the number of characters in the string. Okay? So although this string has 12 characters, 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 12, that is not what length does. It says this is a character of length 1. Okay? There are functions that if you want to say like how many characters are in this. So let's say, for example, you had a vector of IDs or something like that, and you want to say, oh, how many, I want to find the IDs that weren't, correctly formatted and they only have like 4 elements. They're supposed to have 8 or something like that. There are other functions, but that length is not the function you use on characters for that. Okay? So, what's the expected, what do you expect for the length of the name variable? 1. Right? Just my name, just in quotes. What about name 2? Should have 2. So again. So you can perform functions on entire vectors just as you would if it was just one element. So you say x plus 2, what it's going to do is every single element of x, the 1, the 4, the 6, and the 8, it's going to add 2 to each one of those numbers element-wise. So that's why we get 3, 6, 8, and 10. If we multiply by 3, it is going to multiply each number by 3 and give you the resulting vector. You could add 2 vectors of the same length. So x, 1, 2, 3, 4. Remember, it's 1, 4, 6, and 8. So 1 plus 1 is 2, 2 plus 4, 6, and so on. So we will talk about, you can try, and you sadly can do this with a warning, you can add 2 vectors of a different length. And some odd behavior happens, but if you come from other languages, that's not always the case. You can't always do that. For example, MATLAB, if you tried to add a vector with 3 numbers and a vector of 4 numbers, it's going to say that doesn't make any sense. I still don't think it makes sense, but R allows you to do it. And we're going to tell you about the behavior, because if you don't know, sometimes it can give you a warning. Sometimes it can execute and not give you a warning. So it's good to know kind of what you're doing or when this happens. So name 2 was a 2-element vector with my name, John and Michelle. So I try to add 4 to it, and we get this error. Error in name times, we swap these out. Name plus 4, non-numeric argument to binary operator. So, welcome to the world of errors in R. Some of them are very intuitive, some of them maybe not so much. Pretty much what it's saying, a binary operator, right? The plus, it's just adding 2 things. It's an operator that acts on 2 separate things. A non-numeric argument. I tried to add my name to the number 4. R doesn't know how to do that. There's probably no definition for that, right? This is important though, because in other languages, for example, if you do this with a character, other things happen, but you can't add things together. There's a command we'll talk about later called paste. If you want to put the number 4 to the end of every single number, you can do that, but that's not the way you do it here. You want to repeat my name 4 times? You can do that, but that's not the way you do it. You can't add characters and numbers. So, R keeps things in memory, but it's memoryless. It doesn't care what you assign something to be before. And I mean that, we're going to say y is equal to x plus 1, 2, 3, 4. R does not care that I had assigned R to hello world. It doesn't care that before it was a character and now it's a number. It doesn't keep memory of that. So once I reassign this, it will not give me an error say, hey, you already have a variable named 4. It will not do that. And it doesn't care what R was previously. That is gone. Okay? So it's the same operator, still assignment, but if you had y in memory before, it doesn't matter. Y is overwritten in your memory. Y is now 2, 6, 9, and 12. Okay? So this, when we talk about later, is one way you can reassign variables. So if you want to say, age is equal to, age plus 5 or age 2, you can reassign a column in your data set and replace it with a new value if you'd like, right? So when you have a data set and one of the columns is age, you would say data set, age column is equal to something new, and it'll replace the previous values if you wanted to do that. Okay, STR is another function other than length. It stands for structure. So it can kind of give you a quick snapshot to see what kind of object this is. So if you say structure or str on X, it says it's a numeric vector. 1:4. We'll talk about the colon operator. Essentially, that means 1, 2, 3, 4. Just a sequence from 1 to 4 by 1. That's what that colon operator means. And it prints out the first couple values. So it says the structure of X is numeric. It has 4 values, and these are the first 4. And similarly for Y. So it tells you it's numeric, and it gives you the length. If we went to our environment, that is essentially what it's going to give us, is the structure. So if I say X is 1, 2, 4, 8, right? That's what's printing out here. But if you didn't want to go to the environment, or if you're just working with code, you can say structure X, and it'll give us the exact same thing. If I make X to 200, right? X is now, it still says it's numeric, there's 203, and it gives us a quick snapshot. And if we do structure of X again, it'll show us whatever the first 10 or something like that. So it gives you kind of just a snapshot. So str is another function that allows you to kind of briefly view your data to see what's going on. All right, so we created a new script, used R as a calculator, assigned some new values to variables, performing some algebra on some numeric variables. We showed some errors. Now, I believe, so we're going to do the lab now. But I want to show you this. We kind of show you in the lab, but I do want to talk about this before we start doing the lab, because it is kind of a very important kind of gotcha in R. So let's say X is 1, 2, 6, and 8. Oh, not 68. So, gives us a warning. So I tried to add 3 numbers to 4 numbers. So remember, X is 1, 2, 6, and 8. I tried to add 1, 2, 3. It did it. It didn't crash. Right? It didn't give you an error. It gave you a warning, which is different. Right? So 3 things we've shown so far. Sometimes a command will just execute and do nothing. Sometimes it'll execute and give us a warning. Sometimes it'll execute, or it won't execute and it'll fail. Right? Like we tried to do, and it says error. Right? So if I go y equals this, let's do z, and then I try to print z, it's going to say it's not found, because this never executed, this never ran, this never assigned z to anything. Okay, so now let's go back to the case I was talking about, X. So what happened? It said, longer object length is not a multiple of shorter object length. Again, that's true and explicit, but not always the most intuitive of errors sometimes. But this is probably better than most, or better than some. So what it does, it says, okay, you have a vector of length 4 and a vector of length 3. I'm going to try my best to help you out. I'm gonna try to execute this for you. What it does is it takes the first element and sees there's a 1 and adds to it. That's how you get the 2. The second element, 2, adds to the 2, you get 4. Third element, you get 6. You add 3, you get the 9. Now, what happens? It says, okay, we've run out of things on the right-hand side. So I'm going to wrap them around. So what it does, it says, okay, I'm going to repeat this thing over and over again until it makes the length that we need. So that's where you get the 9 again, because the 8 in X is added to the 1 here. So that is the same thing, right? This 1 being the same output, because what it did was say 1, 2, 3. I don't have anything left, so I'm just going to go back to the beginning. Right? That is sometimes helpful, usually dangerous, because that. Notice it didn't say they weren't the same length. It said it wasn't a multiple. So this one's length 4. This one's length 2. Says, hey, your multiple's great. This is really great when you have super structured data. Like, let's say you have a spreadsheet and every row is case control, case control, case control, case control, case control. And you want to be able to fill in case control? Easy. As long as there's an even number of rows, You just say column 3 is this vector case control, and it'll fill it in over and over again. Most times that's not what happens. Most times that's not how your data is. But sometimes this is what you want to do for efficiency. Most times it's not. But you should be aware that this executes is not necessarily what you think it's going to be from the onset, and it doesn't give you a warning or an error. Okay? So let's go to the lab. So if you go to the website, you go to Basic R Lab. Either this will download or it will. Let me copy the link address. So if you are in a different browser, sometimes if you go to this, it should download. But if it does open in the browser, you can do File, Save Page As, and then just say I want it to be. I think you just want to save it as text, I believe. So if that does happen, rather than try to download, just have me come over, just because sometimes saving off the website it doesn't always work so well. It tries to save it as some weird HTML, but that shouldn't be the case. But if it does, just raise your hand. Okay, so we are going to bring that up, and so we're going to probably do about 20 minutes, and then kind of reconvene. And so Leslie and I will be. Sorry, there's a date in here that's wrong. Leslie and I will be floating around, answering any questions, kind of going through. So download it. If you don't have the internet, I can give you a jump drive with it on there. So does everyone have the internet right now? Can't get on. Okay. So let me put the labs, or at least today's labs, on a jump drive, and I'll be right over. Oh. Leslie, do you have a jump? Do you have a jump drive?
Oh, no, yeah.
Huh? You're on now. Well, I'll still. Should be on that. Okay, get that on there. Oops. No, it's not. But I mean, I would still recommend our studio. Just it's significantly easier. It's Monday, so sorry. Okay, so yeah. No, I was just say our studio. Just Google our studio right now.
So this gives you comments for instructions and just try different exercises. You want to change it to Flash? Okay. So you will have it included.
Okay, yeah.
Blue Flash. And then there's an appearance tab.
So scroll down.
Yeah, so it's a
No,
bunch of
there,
different
you
things.
have to scroll down. You can still do everything. It's not that big of a deal. It's just yeah. Usually that's. I think you can still. I don't know about the permission stuff. But yeah, see. Well, let's see if we can run it. Sure. Yeah. Well, it's downloaded, so it's. Yeah. Just scroll down. So Windows. Yeah, I like that one. Save that. Okay, try to run it. Somewhere still down there. Yeah, it takes yeah, while that's going on, do you mind to whatever email I have on assist. Yeah. Well, let's see if it's your yeah. If your name's not on there, can you just write it out? Yeah. Yeah. If you put your email on it. So you can write it. So you go there.
So those are characters you can say, yeah, okay. So I have to do it in,
So you can still work in the script, but if it's in the script, it's a little bit safer. Then so the C function, right? Okay, and so and then do my.num, comma,
yeah, is that what I'm,
my.num. So do my.num. I don't know if it's defined. So you have to set it equal to my.num equals. So you might, but you don't have my.num defined, right? So if you look in your environment, you won't have necessarily a my.num. So if you want, all right, so if you're defining a variable in R, you don't put quotes around, even if it's a character. So on the left-hand side, it won't have quotes. It'll just be whatever you want it to be, right? So for the first one, for example, my.num, if we want it to contain 6 numbers, whatever ones I feel like, you just put the variable. You don't put a quote. So it's not so this. Sorry, you don't put like a single or double quote around that. That right. So there's never quotes on this. And then also, really quickly, so if you put quotes around something, again, R interprets that as a character. So here, if I say my.num equals, and then I signed it, contrast these two with this one. So this one doesn't have quotes. R says this is not a character. This is an object in R, and so it's going to go to the memory, retrieve, say what is this equal to, and then it's going to print that out. So just on the left-hand side, just no quotes, just whatever variable name you want it to be, and this is different than this, right? So when it's encapsulated in quotes, it's interpreted very differently. It just R sees that as a word, not necessarily any indication about the variable.
So the combine
Mhm.
as used in this case, what are the three?
So combine. So the C function is the combine or collector, right? So when we sorry, that maybe that's a little ambiguous in the question. When we say combine, make a vector with both of them in it. Don't paste the strings together. Just make a longer vector with my.num and my.car. So you use the C function for that. Just like we've collected elements here, separated by commas, we're just going to collect those two vectors in there. So we aren't going to be putting in numbers, we'll be putting in the objects. Again, without quotes. Because if we put it as quotes, that means something completely different than if we put quotes. We didn't put quotes around it. Right? So this to R is saying, take this character and this character and put them together in one vector. Whereas what we're trying to do in that question is take two different vectors and put them together. So you have to leave off the quotes so that R knows you're looking for objects rather than combine. Yeah. If you wouldn't mind, that's thank you. Sorry. Go ahead.
These aren't all.
Sorry. RStudio. And then
So I have to do my
should we RStudio?
not no comments here.
That thing right there. Just you can create a shortcut so you can right click. Create shortcut. Or copy. I think copy. Then if you go to your desktop, it should create a shortcut. And then if you go to desktop, wrap it up. Paste shortcut. So go with that.
This is the first one. I tried to do it before, but I guess I didn't want to. Okay, you want to do the desktop one? Yeah.
So second orange probably.
I just want to make sure that you did them.
So they're all wrappers.
Okay, there it is. Yes. So I had this. I just want to, if you Google RStudio, right? RStudio. Yeah, I used the first. Okay, yeah, that's fine. I think, do I do the zip?
Yeah.
No, it's fine to do that one, because that thing, when you click on it, it gave you what's on your desktop right now. Oh, that's your desktop. Try double clicking it again. Yeah, more or less. Yes. And every time to bed.
usually both.
So notice that when you have only one set of traits, that only
So the DHS, yeah, if you subset columns, based on like, so if you subset columns.
I'm on step number 7, but I don't know if I did the
So
number
let's say
9. I don't know if I did the vote. Did you get a link?
The other thing is to look at the yeah, yeah. You can't turn off. Yeah, so those are the so yeah, no, yes, they're right. So function has whole associated set of methods. So I think the answer is I'm giving it very non there are yeah, no, yeah, just like you.
So I did my 5 characters.
So I'm talking about so now when I'm
But when I did it,
historically
it's oh, it's mine. Oh, this is, oh, okay. Okay, okay. Okay, I see.
it's more common. I mean, it's, I don't know. People are people are
Oh. I want to learn efficiency.
oh,
Oh, basic are, oh, it's saving the diagram. So this is my new file. Yeah. What I'm trying to do now, what I need to do is to take a string, have a letter, put it on the and then. Yeah, so I have to recommend on the simple writing. Set me on the 0. And then I want to put dates. Dates are always like oh, so. Oh, no. Oh, and then now I change it just right 10. Right 10. Right. Seems like they're being adjusted. Okay, yeah, so much fun.
We're gonna take 2 or 3 more minutes and go over the lab. The second lab. No, that's for the next lecture. Okay. Okay. Go back. 5, sorry. No. File preferences. Or sorry.
Oh, that's not the way it is.
I don't think there's a way to upgrade R to the newest version through our studio. So you have to go to the R website and download the newest version of R. Yeah, it should have
Pane layout.
You don't need to do anything with our studio.
Just that
Like,
there.
it has R
And the
version
coding,
1, but you wanted
let's just
the
apply
newest
that.
version.
We just,
You just go to the R website.
That's the way it is.
You don't need to do anything with R.
Okay, yeah.
oh, that's right.
So, if I wanna save
No, it'll just replace.
statically,
When you download the new version and install it, it'll
Oh,
automatically.
these are mine. Yeah.
So, yeah. So we don't. We're not going to use log files.
Both are not.
We're gonna. I mean, so essentially, you can have a code
Our
that would be
updates,
totally executable, and then you
like
save
very
your
small updates, maybe.
or save like a
Our studio files are that long. But they're even okay not using.
So we'll talk about that a little bit later. But data input output in the next lecture, right? So a lot of times logs are good, but scripts are better for a lot of reasons. You can execute a script.
No.
Generally,
Because,
R
like,
doesn't set
unless
itself
you
up
are
very
using a package,
easily for the kind of logs that it has. But during the way, we're going to show you, or in the next lecture, I'm going to show you that you want to save this thing out. So there is a save function, which will save all objects, or writing CSVs or something else like that out as intermediate files. And then towards the end of the lectures, we'll talk about this way to integrate code.
this interactive way of communicating, just you can see the.
You can see it there, exactly. But if you go to your history, and if it was so, if you write it, for example, so let's say like my document, like equals 4, and I know this is what you're doing. If you hit Control Enter here, it'll execute that. So you can be writing in the script and then execute. That's make sense? Yeah.
So.
Yes. Yes, you can open Yep. So there are 2 different ways. So one, you should be able to click that button. Or I think tools should be set on your directory. No, session. Set working directory. And then there, set working directory. And then choose directory. So you can save it to where you want. And then there's it's a set WD as a function in purpose.
I think it's always difficult. But it's,
Yes.
I works out. Something like that, it's not.
I works out.
Okay.
Good.
It's more for.
All right. So I'm going to give me 1 second. Give me 1 second. Sorry, I just want to make it so. Sorry, this is just something so that you can see the keys. Okay. Okay, so sometimes it takes a minute to refresh, but if you go back to the web page, see, refresh this a few times. Okay. Probably just get some warning there. But there should be a key. If you refresh the website now from where you download it, there should be a key. So we're going to open that up. Alrighty, we're going to walk through these step by step. Save. Get rid of that. Okay. So we're going to create a new variable called my.num, and it's going to contain 6 numbers. Okay, I'm going to just, so this is again, okay, so this is the way I tend to work, even though it is interactive. You can type in over here. I generally type my code in the source and then run it like I was talking about before with Command Enter. So it actually executes the code over here. If I wanted to print it out, I would still write something like this. And then I would I would comment that out or delete that if I didn't want to, if I just wanted to view something interactively. Okay, so again, we're collecting 6 numbers together. Didn't matter what those numbers were. We will talk about the seek and the colon operator, right? So you could have said 1:6. There's also seek 1 to 6, which will do a sequence of numbers. By default, with steps of 1, you can do a sequence from 1 to 6 by 1/100ths or something like that. So we'll talk about those a little bit later. But again, just collect 6 different numbers. Assign it to my.num. Again, there's no quotes. There's nothing over here. You can put periods in here. You can put underscores. You can't start it with a number, right? You can't start it with certain operators. But we'll talk about the definitions of those before or a little bit later. But my.num times 4 multiplies it by every single element by 4. We're going to create a second variable called myCar that contains 5 character strings. Okay, so I think this was a little bit misleading. So we did put my.car in quotes just so that you knew that was a variable name, but maybe that is a little misleading because on the left-hand side, you still don't put quotes. You do not put quotes around my.car. And here we're just putting Andrew, John, John, Andrew, John, 5 times. Okay? And when we say combine, we're just going to put these together. We're not pasting things together or anything like that. We're just putting them all in one vector. Right? So let me print this out. So one thing. Let me both my.num. What does this output have? This doesn't. Quotes. So that should at least give you an indication what number 6 is going to be. So what's the length? So my.num has 6, my.car has 5. Both should be 11. Okay, we see that it is. Also, that was what I was talking about before about these little brackets. You can at least get the gist of it. It's not a solid way. It's not a consistent, rigorous way. But if you want to get just a gist on how many things there are, you see 9 here. You can see there's 9. It's the 9th element, 10th element, 11th element. So you can get kind of a ballpark on how many there are. Do not use that as just a very gross gauge. If you're trying to say is there 100 cases in our data set, you would still use operators like length or the number of rows or something like that. So what is the class of both? Character. So again, vectors have to be of one class. We see there's quotes around here. We see that it became a character. This is what's called coercion. So R doesn't know how to make a character into a number, right? But the way it thinks on how to make a number into a character, it says, okay, we're going to put quotes around it. We're going to treat it as just as like every other word. So although my.num had numerics in there, and I can do my.num plus 5, when I try both divided by 3, we should get an error. Non-numeric argument to binary operator. Again, because even though there were numbers in my.num, after you put it together, after you collected it into one single vector with my.car, it said, hey, I don't know what you're doing with these numbers and characters together, but I assume you want to make these numbers into characters, and I'm going to put them together for you. Again, no warning. A lot of times you do, I wouldn't say you definitely want to do this, but there are a lot enough cases where you want to do this where a warning is not kind of warranted. It's kind of prohibitive in some respects. This is not a true warning. Ours is kind of like a catch-22. It's flexible, but if you don't know what you're doing, you can kind of burn yourself with some of the things if you don't know some of these catches. So, is that clear? So we had, like I said before, when you run a data set, if every single age was a number, but one of those cells had a space in it and you didn't tell R that spaces meant missing, it's going to say, hey, this is a vector, this column is a vector, they all have to be the same class, one of these is a character, even though all the rest of them are numbers, I'm going to make this whole thing into a character. Okay? Does that make sense? So when we combine them together, because vectors, again, same class, or same, sorry, I keep saying class. What I mean is same data type. Numeric, character, logicals. We'll talk about logicals and factors a little bit. Okay, so we're going to create a vector with elements 1, 2, 3, 4, 5, 6, call it x. Create another vector, call it y, 10, 20, 30, 40, 50. Again, what happens when you add it? It works, but it gives you a warning. So what it did was 1 plus 11, 2 plus 20, blah, 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 all the way up to it gets to 6. Don't have enough elements down here, so it adds to the first one and wraps it around. This is called, if you Google it, it's usually called the wraparound effect in R. Now, if we append y, we append the number 60, we add them together, no warning, everything happens element-wise. Again, if we multiply, everything works like we assume it kind of would. It multiplies each one element-wise, and so on and so forth. Okay. Does everything in there make sense? Yes. Number 5. Yes. Okay. So my.num is this. My.car is this. So we want one vector that contains all this information. Maybe it's not the most intuitive example, but that's what we want. Okay? So sometimes, for example, let's say my.num actually weren't numbers. They technically were IDs, right? In a lot of studies and that kind of stuff, IDs aren't truly numbers. You don't want to be able to add 5 to them because that'll make a completely new ID, right? So maybe, data set 1, data set 2, data set 1, it had them as numbers, right? Just by the way it was read in or something happened to the data or something like that. Data set 2, they were characters. And you wanted to combine it into one big list of IDs, okay? That's maybe a more intuitive case about what we're doing. What it will do is say, okay, these are numbers. I don't know how to make characters into numbers, but I know how to make numbers into characters. I'm just going to treat these as characters. And so that's what we actually get when we combine them together to get both, to get the variable both. So it says, hey, this has to be all one class. These are characters. These are numbers. I'm going to change these to characters and then put them together. Okay. So we will be talking about other functions that will do this explicitly. There are functions like as.character that are very explicit about doing this. To say, like, I'm not trying to combine this with another character vector. There are functions that say, like, I want to make it so this is a character. No matter what was in here, if numbers were in here, if characters were in here, I want to make sure it's character. So we'll talk about those a little bit later, right? And again, you see it's in quotes, so you know that this actually was coerced to a character. So that being said, there is one, for example, like as.numeric. We'll talk about missing data later, but again, both had those names and it had the numbers in there. When you say as.numeric, it says, hey, I want to coerce this, I want to change this, I want to make sure this, you give it back as a numeric. You can do that. It's just going to say, if you didn't put numbers in there, I'm going to give you missings back. This is warnings, NAs introduced by coercion. And these were all the Andrew, John, Andrew, whatever. So it knows that when the number 5, just with quotes around it, it knows how to make that into a number, but it doesn't know how to make words. It knows when there's quotes, not commas, doesn't like commas, right? It knows how to change certain, like numerics into, characters, right? This still R, this is in quotes, R treats it as a string, that makes that a 5. This one has commas in it, right? So some of the data you get might be in thousands of dollars or thousands or something. You have to strip those away before you change them into numbers in R and stuff like that. Okay? So, is at least all these examples pretty intuitive, or not intuitive, but are they straightforward so far? Okay, normally we'd have like about a 10-minute break. I'm gonna allow people to kind of break during the lab because we started off a little bit late today, and I don't want to hold people later than they need to be. So if no one has a very strong desire that we have to like get out of the classroom right now, you just hate my voice, you gotta leave. No, we're gonna charge forward. All right. So cool. We played with vectors and numbers, right? We have no data so far, no real data. So that's what this lecture is about: getting data in, getting data out. And I spoke with some students, and we will talk about things that are like logs, but there is no real direct analog in data of logs in R, right? So generally, what you have is a script that executes code and saves things out, whether that be a CSV of a table of output or something like that, or a figure, or there are some things called there exist are object folders. Right? So trying to use the word our and are, or the present of exists and are is kind of a hard thing to say sometimes. Okay, so again, working directory problems. These are probably the biggest problems you'll have when you're trying to read data in more or less any language. You have to make sure you're pointing that software to where the data is, right? I try to use everything with relative directories, like I did before with data slash. I try to use nothing with absolute directories, like I was saying before, C:/ my username, stuff like that. So we will show you a way, in our studio, it allows you to do that relatively straightforwardly. We're going to have a drop-down menu. We're going to show you with one drop-down menu how to import some CSVs and stuff like that. So there are going to be some drop-down things, but for the most part, what we're going to do is use that drop-down menu, get the code, copy and paste that code into a script, and then you would run that script from there on out. Again, case sensitivity. This is not as big of a problem with tab completion, but with data sets, if you don't call the variable name, the column name from your data set exactly, it's not going to return the right thing. They can have the same name, just different cases. And some of them can be very, very, very long and complex, depending on how you import the data. So use tab completion, hit tab. Data type problems. So again, we will be talking about data frames. The only thing about data frames that are kind of not so great is it shows you like a spreadsheet like of the data, but it's not always 100% clear. Is this column encoded as a number or a character? Right. So some of those commands we talked about before that I didn't go over yet. The as dot, the as dot character is something we can say. Make sure this is a character. We can use those in manipulating our data a little bit later. But if you just read a data set in and say like histogram of age, and you haven't checked that column is numbers, you're not going to get the thing that you want out. You're not going to get the right plot. So just general typos with reading data, again, if you have some brackets and stuff like that. So working directories, one of the banes of existence of programming, these data input out. So again, you can change directories and scripts. I suggest not doing that. So there are two functions: getWD, stands for get working directory, and setWD, set working directory. If you have RStudio closed completely, and you open here, let me close out RStudio, and I'm going to open the key. Sorry, this is the key, and I click it. It's going to open up an RStudio session. It's a terrible example because it's in my downloads. Give me 1 minute. So let's see, intro to R. So we are in the data input output. Sorry, this is very small. I'm going to click the data input output.r file. What that will do, because I have my R files associated with RStudio, it's going to open it in my little browser, and it's going to automatically set the directory to the directory where that file exists. So if I start this project tomorrow and I open it like that, it'll always open in the directory where that script is. And then I usually do everything where it's like, read data point, where it's like, data something 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 something, where it's always relative to the directory of the script. So sometimes you still want to set working directories, but again, that's not at least the way the code's going to be set up for this. So R is going to look for files on your computer relative to the working directory. So assume you're in the directory the script is in, it'll open. If you if you are going to set a working directory, set it at the beginning and top of your script. Do not set it in the middle. Do not set it 5 or 6 times, flipping back and forth with you're going to this directory and that directory and that directory. Because when you go to give that code to someone else, it is very hard to rerun.
Can I just repeat what you said to make sure I understand?
Yes.
So,
Mhm.
I work in state, so my brain. So you're essentially putting your script file in the folder where all your data will be. So it knows to go to that folder when it goes to storage.
So that's a good question. Usually, I will read the data relative to that path. So in a sense, I usually have a folder that says programs, a folder that is data, and my scripts are in the programs. So for example, I would do read a CSV, go up a directory, go into data, and then read that. So level up, data, and read. So my folders are still separated between code and data. We will talk about this a little bit later, but this is a good question because there's just different ways people are doing it. All I'm saying is this is relative to the script or relative. This is a way to relatively specify where data is. Versus if I say that, right? Let's contrast these, right? This will work on my machine. This has the potential to work on somebody else's machine if I copied over the entire folder, for example. So later, we will talk about these things called RStudio projects. So I'm gonna, sorry, it's really small to see this stuff on the big screen. But if you say File, and I'll show you how to do this in RStudio. File, New Project, and you should note here that up here in the right-hand corner, it says I'm in a project. That will automatically set it to the directory where that project file is. So then you can do things relative to that, for example. So if you open that project and start running code, you know you're in that directory. Versus opening a script and assuming you're in the scripts directory. Does that make sense? So there are different ways, but it's just a one kind of a project management idea. But the big thing is, the big message is in here. If you're going to do reading in data or writing or whatever, make sure it's at least somewhat relative to that path and not hard-coded, using your username or something like that. And at the very least, if you think it's going to be in someone's Dropbox, all right, we'll talk about the tilde in a minute, is the home directory. Okay, so this is kind of what we were going over, just not as structured. Okay, so the default directory structure uses single backslashes, but R interprets these as escape characters. Sorry, there should be a slash there. That should be in there. So you must replace the backslash with a forward slash or 2 backslashes. Throughout the entire course, writing in anything with respect to paths or anything, use the forward slash. So if I'm typing C:, I'm using that in Windows. I do not use that because that is the way you have to do it in R. And I'll say that in the sense, okay. You can still use backslashes. I always have to think, so it's like you're slashing forward, you're slashing back, right? So this is a backslash. So Windows users, they're used to like one of these, right? C colon like that. That for most systems is not the way it's set up. So more or less, don't use these. Use a /. There are a lot of reasons for that. I can go into them, but just don't use these. And if you're going to use them, you have to use 2 of them. So the tab completion in RStudio will allow you to do this. With Linux and Mac, you don't have to worry about this. They use the /. But note here, when I say C colon / this quote, and I hit enter, you see a plus here? That to R says you're not finished. That command isn't done. I expect more to come next. So if I just keep hitting enter, you just keep hitting these pluses and nothing executes. That's because the /, it says, open quote, C colon, this is interpreted as what's called an escape character. So that means if I actually want a double quote in a string, I can escape it. Again, we're not going to go into this in any more detail. More or less, that backslashes can cause a little bit of problems with respect to paths. Just use the /. But again, use it relative to the directory. All right, so the other shortcuts. So period goes up a level. So if you're in directory A, the directory above that is period. Right? So this is just kind of how you specify directories on your computer. So period goes up a level, /, period is the current directory, or dot. Okay? So you say like, so if I say set working directory, period, it's going to go up a directory. And in fact, I can keep doing that, and it'll go up 3 directories, for example. If I do this, or this, it'll set it to the exact same directory that I'm in. Again, when we use the drop-down menus, it shouldn't be as big of an issue. The tilde is your home directory. Again, this is really important if you're sharing code with other people, but programming is getting code working and then getting it working for someone else. That's kind of the second step. So, yes.
Is there a command to show, to display where you are?
Yes. So one, you can look up here on the console, but that's not helpful if it cuts off. Get WD is get the working directory. So again, there's some file helper functions. So dir will display the contents of a directory. So if I say dir period, it says, tell me what files are in this directory. Dir period says, tell me what files are in the directory above me. That kind of stuff, if you just want to do things without looking at the point and click. So we talked about this, absolute and relative paths. You can also, instead of using setwd, if you want to set your directory, and this is kind of the way you think, you can go session, set working directory, choose directory, and it should pop up and say, where do you want to set your directory to be? So that's one way you can do it. If you go session, set working directory, you can say to source file location, which will set the directory of this file path. It can also set it to whatever's in the files pane. I don't use that. But if you do want to set it explicitly, if you had changed the directory and you want to change it back, you can use this drop-down menu.
And then if you're in the right directory and there's subfolders of data, it will just search those folders for data.
You have to explicitly specify it. So if so if there was a subfolder in data, you'd have to say like data / subfolder. Because you could have, for example, Baltimore employee salaries FY 2015. You could have that in the data folder, in the subfolder, in one of the subfolders, right? So you have to be explicit as to where, which one it is. Does that make sense? But for the most part, we will show file import data set will be what we're going to use. And I'll show you. So from CSV, and I can click browse, and we can say, I want to go to the data folder, and I want to get that Baltimore data in there. Sorry, I think I have to make this a little, not that small. So it's gonna show us a little preview. All right, let me redo that just so I can. This is also in the notes. I just wanted to show you one way we can do this, but you have to worry about all this kind of stuff. Okay. So put the directory. Show you a little snapshot. Say some of the options. Is your first name, is the first row actually a header row, or is it just data? Do you want to trim some of the spaces? So if there's spaces on either ends of like words, right? So if it was like space, John Michelli space, it would trim those away. Do you want to open the data viewer after you open the thing up? It's a comma delimited file. You know, comments are, you can specify there's something else. NAs, you know, do you want them to be just empty strings, stuff like that. And when you click import, so the nice thing down here is it gives you the code. So it says we're going to bring in this other package, we're going to assign a variable, and then it's going to view it. And if I click it, it reads it in, it brings up a viewer, and there's your CSV loaded in memory. So again, we'll get to that in a minute, but this is the way you can do this quickly. If you're new to R, you want to get a data set in there, you want to be playing around with it, you can use the file, import data set, and you can see that it has multiple options. It has CSV, Excel, SPSS, SAS, or Stata. If you want to load one of those in and start working with it immediately, it'll give you the code. So now you can copy and paste this code into a script, and you will have a script that'll load that data in. But again, these are absolute paths, so it might not necessarily work on the next person's computer. That's all. Okay. So again, we'll get to that, but we're talking. So before we talk about any of the functions, we're going to talk about help. So the way you can get to help is the question mark. So you say question mark and then function name. So dir was the function we talked about before. If you execute this in your R, it'll come up with the help directory for, in the bottom right hand corner, list the files of a directory or folder. Right, we see, you know, this is the help file for dir. It has all this information. It shows you, this is the usage, this is how you use the function. These are the arguments. These are what the arguments really mean. It gives you a little description and a title. And you can also use the help function explicitly. So if I help dir and put it in quotes, that'll also bring up this help. That'll also bring up this directory, or sorry, this help file. Okay, so everything will be using publicly available data. We will talk about, you know, not any of the examples, not any of the labs or anything are going to be really toy data sets. We will go through some toy data sets in the lectures. They're from Open Baltimore or data.gov. So reading in data is usually the first step. It can read in almost any file format. So it can read SAS, it can read Stata, it can read SPSS, it can read in, you know, any type of CSV with delimiters and strange things going on there, Google Sheets, that kind of stuff. That's not to say out of the box R can do all that. A lot of these reading capabilities come from external packages, add-on packages. So for example, if you downloaded R, loaded R up, it wouldn't necessarily be able to read in a Stata data set if you weren't using RStudio, for example. So some of these user-written packages people wrote it so they could read these other things. But general, you know, text-based data, read it in off the bat. So we're going to be talking about usually text delimited, tab delimited, comma separated using either commas or semicolons. And then we're going to be using show one or two packages to read Excel files. So we're going to be talking about the youth tobacco survey from data.gov. So it's about smoking and smoking cessation in youth. So you can download the data. So if you have this, we're gonna click, and we're gonna show you what happens when we click this. It's the youth tobacco survey. It's gonna come up with the CSV, right? And so if you get something like this in Safari or Chrome or something like that, and you actually want to download the data, you say File, Save As, and it should download the data. not as a web archive, but as a page source, and you can download that wherever you like. You can also read in CSVs from the web directly, right? So I'm going to show the code where we actually just take this website name and we're going to pass that into a function to read it. Okay. So I talked about this, and that's what we're going to do. So I'm going to go into R. I'm going to say File, Import Dataset. It's a CSV. So I'm going to first, I already downloaded this somewhere, so I'm just going to grab it off my hard drive just to show you how to do that. And then I'm going to paste the CSV path directly from the website. Yes?
I get a message that says preparing data report requires updated versions of the following packages.
So yeah, usually, so if it should give you an option just to update those. Yeah, so some of these, so RStudio on the back end, so you'll see here the code that it gives you calls a different package to read in that data set. So it depends what version of RStudio, but if you don't have necessarily the most up-to-date package on these, it'll tell you to update them. Okay, so I'm going to go to my desktop. I got the Youth Tobacco Survey. Gives me a little preview. Name, I'm just going to call this YTS. Okay? Because although it's called the Youth Tobacco Survey YTS data, by default, it's going to try to make that as your variable name. That's a really long variable name, something you don't want to use over and over again. Right? I'm just going to call it YTS for simplicity. Right? Again, because the way I zoomed in, I can't really get a good view of what the data looks like, but I know this is a header. I want to keep all this stuff in there, and I'm going to open the data viewer again so we can take a look at it. So this says 9,794 entries. We can scroll through, we can filter things, so we can take a look at this data as it's loaded in memory, right? So we see there's a whole bunch of variables here, so we can filter, right, based on, let's say, Arizona, right? So it says showing 1 of 6 of 240 entries. Filter from that. So if you want to do some interactive browsing, that kind of stuff, you can do that in this viewer. Okay. So that's one way you can download it. That's one way you can read a CSV. So these drop-down menu. Like I said, we have this code. And I would copy and paste that into my script. All right. So now you have this data set in there. We will talk about data manipulation, but just getting into R, that's kind of one way you can do it. Again, if you really briefly, I told you I would do this, we can do File, Import Dataset from CSV. I can paste it directly. It'll retrieve it. Again, I'll call this YTS2. Or sorry, I should name it here, YTS2. And sorry, move this around. Execute. So again, exact same data set. So it does give you a little bit of output. So it says parse with column specification, year. It assumes it's an integer, data value. It says it's a double. So it's saying like, I think these are numerics. I took a guess. If you wanted to be specific as to what they were, you have to specify it directly in there. But for the most part, it's really good at guessing. And if it does come into the case like we were talking about before, where it has something that's non-numeric in the numeric column, it'll make sure that's a character. So it won't won't delete or throw out data from your files without at least without telling you. Okay. So what's actually going on behind the scenes? So that read_CSV function really is backended by this function called read_delim. And as you saw before, it used this function library, right? And it used readr. So readr is a package that the RStudio team had written to read in CSVs and tab delimited files in a more efficient and somewhat smarter way than the defaults are in R. So there is a read.csv function, if you had downloaded R, We are not going to go over that because the defaults are a little bit strange. So mostly every single data set that I see in the school of public health, I'd say maybe not everyone, 90% they have headers, right? Column names, right? Read.csv doesn't always assume that. So more or less, when we're talking about reading in data, we're going to be using the read.r package. So this is the first package we're going to be talking about in this class to read to do anything with, and it's going to be to read data. So the function that goes on in the background is read_delim, and these are all the arguments. So you can see you can customize this reading in a lot of different ways depending on how, let's say, interestingly formatted your data is. So you can skip certain rows. You can trim white space, for example. You can specify a different delimiter if it's not comma separated or colon separated or something like that. And all these other more or less functions that most of the time you don't need, especially if it's formatted from like an Excel or some other standard format. So you have to specify the file name path. The file name is the path to your file, either relative or absolute. It has to be in quotes. Again, if you specify a relative path, it'll look in your working directory. You can also specify a website URL. Yeah, we're not going to go into exactly that. So, okay. So again, because at least the way it is on my computer, where this code was executed, one level up in the data directory, this youth tobacco data set was in there. We assigned it in this case to be DAT, right? YTS or DAT, whatever it doesn't matter what you name it. So now the data is successfully in your workspace, and you can just run all the types of data manipulations, right? So read_delim and related functions return this thing called a tibble. It's kind of a play on the word table or something like that. I don't know. But like we said before, there's a bunch of different data types, right? So we talked about characters and numerics. We'll talk about logicals and factors or categorical variables a little bit later. And now this object in R is not a vector anymore. It's a data frame. Okay? A data frame or a tibble. Which means it doesn't just have one dimension, it has multiple dimensions. It has rows and columns. Each column now can be of a different type. So before, vectors, when we took my.num and my.car and put them together, it said make everything a character. That's not the case anymore. Now you can have one column with numeric, one column with character, one column with whatever, right? Just like an Excel spreadsheet, right? It doesn't necessarily all have to be numbers or characters or anything like that. So we will use read_CSV to read almost everything in here, or to read CSV files in here. We will use the read.r package for almost everything that can read, standard text data. We will use a different package to read Excel data. But the reason I'm making such a point about read_CSV is because if you see any questions online that ask about reading in comma-separated values, 90% of the code, I would say, use read.csv. They use read.csv for two reasons. Well, two big reasons. One, it comes with base R. You don't have to download anything else. Read.csv is in R when you start it up after you immediately download it. You don't have to download this additional package. Second, read.r has only been around for maybe about 4 years now. But the reason we use it is it's much faster, it's a bit more intuitive, it has better defaults, and it works with RStudio. All right, so although the view function is really helpful in RStudio, you saw you can filter and do all these fun things. A lot of times when I explore data, I don't use that viewer. I use the function called head, right? What head will do is it by default will print the first 6 elements of something. And if that's a data frame, it will print the first 6 rows. If it's a vector, it will print the first 6 elements. Usually, I'm using that to get a gist on what's going on with the data. right? What are the columns? What's kind of some of the values in there, right? So you can see here, year, it's an integer, 2015, location abbreviation, location description, topic type. So it's got a whole bunch of variables, right? We saw in the viewer it had like 100 variables in there. But when I'm printing this out to the screen, head says, hey, I don't think you want me to fill the screen with like hundreds and hundreds of records or hundreds of columns. So I'm going to shorten it up. Okay? I'm just going to show you a couple of the columns, and then I'm going to tell you all the ones that I didn't present. So here it shows, let's see, the first 1, 2, 3, 4, and it doesn't show the other 27. So we'll talk about how to select the specific columns you want to view, that kind of stuff. All right. So if I just type out, instead of writing head, if I just print it out, by default, these Tibble objects will print out the first 10 rows and then talk about, you have this many more rows we didn't present and these other columns we didn't present. Yeah. So we do talk about read to lim and read.csv because that is how a lot of code is read in online. That's how a lot of code you'll get from collaborators is read in. But we will try to start you out using read_CSV because I think that's a much more intuitive way. But you should still look at the syntax and look at the help files for these functions because their behavior is very different than read_CSV and read.csv by default. So for example, read.csv will give you just a standard data frame out, not this Tibble thing. And I say that because when you print them out, it looks different. It doesn't tell you the type of the column. It doesn't tell you it's an integer or a double or whatever. It's hard to see here. Maybe I can make this a little smaller. It prints out every single column, right? It just keeps printing and printing and printing and printing. It doesn't just limit to the first 4 columns. It prints out over and over and over again. So that's sometimes better if you want to see all the columns, sometimes less intuitive. But if you do class and see that something's just as data frame, it'll print out like this versus a different object. So again, let's step back. So we have the data in memory. We call it dat, right? It's got columns, it's got rows. So it doesn't just have the data in there. It has the attributes that we just talked about. Column names, row names. So one way where you can rename the columns is with this names function. So you can use column names or names. They both do the same thing in this case. So you say the names of dat. I want to say the first element, and I want to call it year with lowercase. By default, when it's read in, it's all caps, year. Then I want to rename the first column to year, lowercase. So after we do this operation, so again, this is a function. We want to grab the first element of the column names, and I'm going to assign that to year. So I'm going to step through each different level of this function. Right, so names, or column names, maybe a bit more intuitive, right, gives us the column names of that data set. Okay? One, and we'll go into a lot more detail in the subsetting, but this is a brief kind of just jump into subsetting. Bracket 1 grabs the first element. Okay? And as we just saw from up here, the first element was year. All right. Note that the first element of things is 1, not 0, like it might be in some other things. So it's just a 1-based system. The first element is assigned to the index 1. Now, when we do this, We do say, here before, we were saying get the column names, subset the first one. Now what we're actually doing is reassigning that to a new column name. And in this case, we just called it year, all lowercase. Okay? So, when we look over here, we see it's no longer capitalized, it's lowercase. So, this is important because we have a function on the left-hand side that's grabbing something, subsetting it, and it's reassigning. Okay? So this is why I would say R syntax can be pretty confusing. Because on the left-hand side, you can reassign kind of many things. Right? You can reassign a variable name, you can reassign a variable, you can reassign a column of a data set. And in this case, we are reassigning the first column name of this data set to a new value. Okay. Again, we'll talk about some more intuitive ways to do that, but this is one of the ways. Like read underscore CSV, write underscore CSV, like read underscore delim and write underscore read underscore CSV and read underscore delim, there are associated write functions. So you want to write a CSV out, right? Let's say you took a data set, subset it, manipulated, made new columns, merged it with like 5 other data sets. You want to set that back out so you can send to a collaborator, right? You do all the manipulations, you do write underscore CSV, and then that'll be a CSV on your computer. You can look at it in Excel or whatever, and then you can send that along. If you want to tab delimit it, for example, you can do that with write underscore delimit. And there's options to say, what do you want the missingness to be? Do you want it just to be empty quotes or NAs? What is the delimiter? In this case, it might be spaces. You might want tabs. You might want semicolons. But in CSV, by default, it's commas. And then you output it. I'm gonna kind of breeze over that really quickly. So in this case, we're going to do the same operation we did before, except we're going to assign it to a capital Y for year. And then we're going to write it out. So if we run this command, I'm going to use YTS. 2 things I want to say. Okay, first off, we pass in the data frame, and then we say, where do we want to save it to disk? Okay? If I don't put any other path or anything like that, if I just put the file name, by default, it'll go in whatever directory I'm in. Okay? So the only thing we've done to this data set is just change a column name. And we output it, and then I'm going to open this up. And then if I open this in Excel, so one, there is a CSV here. I'm going to open it up in Excel. And I'm going to show you the first column. Year is lowercase. Sorry, I can't. There we go. Year is just lowercase year. Right, so that's all we did. So again, not anything, groundbreaking or anything like that. But whatever, obviously we're going to talk about filtering, making new column names and all that kind of stuff. Right, and then you can output it using your read and write functions. But I know we haven't gone into detail exactly what these data frames are or some of these other things. But we want to allow you to get data in relatively quickly in this class. The drop-down menu from RStudio is a really helpful solution, and it'll give you code off the bat to get data sets in there. So my suggestion, at least starting out, use the drop-down menu when you're trying to get in CSVs or other delimited data, or SPSS or Stata. Grab the code there, copy and paste it into a script, and then you're kind of ready to go with some data in there, with some data in memory. Okay, that would be something I would suggest. This is a relatively new way to do a new development, I would say. So that wasn't available about 1.5 years, 2 years ago. So I would say it's a really good. So especially if you're using Excel, you can use the read Excel package. I'm going to show you, for example, how to read an Excel, and you should. I would highly suggest playing around with this. Playing around with the data input with reading in, writing in data. It says the first rows is names, and then I would say maybe incidents. Sorry. So for example, I can copy and paste this code. So I'm going to get out of here. Copy that code, paste it in here. And now if I run this code here, although it's got an absolute path, I should be able to get that data set into R relatively easily, relatively quickly, without necessarily knowing anything about the read Excel package and the read Excel function. But you now have a data set that you can manipulate, you can view, you can start cleaning, summarizing, and that kind of stuff. Okay. So we will talk about. Most of the time I would say I use CSVs. It's because it's an open format. Excel's got a whole bunch of stuff in there. I use CSVs for a lot of things. Sometimes that's not always the best way to store data, but I use the read underscore and write underscores functions for that. The read Excel package is very good for reading in Excel. It doesn't really do that well. It doesn't write Excel out. That being said, if you've read in an Excel file, you can always output it as a CSV, and that should always be able to be opened in Excel. That being said, if you really, 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 really need to write out an Excel spreadsheet, XLSX will do that. But I would not. I don't know. Maybe you have a use case where you really need it to be an Excel file versus a CSV, but I really don't have any of those cases where I can't just output it as a CSV. Okay, so these are some packages that I don't know. I haven't used the drop downs to read in SAS, SPS, or anything like that, but these are some really good packages that have come out relatively recently. Haven can read in SAS, SPSS, or Stata formats. Read Excel, which we just talked about. Readr is what we're going to be using for CSVs and other tab delimited. It is much, much faster than the stuff in R. SAS7 BDAT will read in SAS7 BDAT files, which is for SAS. The foreign package, that used to be the go-to for reading in SAS, Data, and SPSS formats, but that's kind of fallen by the wayside given Haven. And then there are other packages that have come out. Like, I think there's Read Stata 13 or something like that, because the different versions of Stata outputs have been changing over the years, and I'm not 100% sure that the Stata formats, all Stata formats can be read in by this package. That being said, if you're in Stata or SAS and you output something to CSV, you can read that in R just the same. All right. So, take-home messages. 1, the read R package is good. Use it. 2, the drop-down menu for reading in data is pretty well set up. It gives you a good intuitive interface starting out. Use that. That being said, as you go along, you'll probably just start using the code. Right, read underscore CSV, using that function, rather than using the drop-down menu. It's not to say it's bad to use that drop-down menu, just usually for efficiency, over time, you probably just get used to the code. I would also suggest copying and pasting the code from the output into a script so that you can reproduce this, whatever analysis you're going to do, whatever cleaning you're going to do. It's nice to read the data set in and do some exploring, but you should really save that data into a script. Okay. So, we have another lab. I was going to say we take like 5 minutes for 2 reasons. One, I want to get like 2 minutes of questions because it's kind of a lot. It's not that intuitive yet as to what we're doing. But for the most part, at least for this course, the way we designed it is that we assumed most of you, what you want to get into are and start working with is Excel files or rectangular type. Right? That being said, a Stata or a SAS format, you can get that into a CSV. So either Excel or CSV. If you have something like, I don't use those formats, I use this format exclusively, we would love to hear that, but we haven't really run into those very specific cases yet. So we are going to do a lab. So I was going to say we take about 5 minutes, reconvene, but you can start on the lab now. We're going to go over it in about, I would say, a half hour, and then kind of wrap up and talk about what we're doing for the next lecture. If you did the TryR module and you're taking this for a course, you can send me just a snapshot of the badge or a snapshot of the completion on Code School. That is totally sufficient for that. Okay.
I'm just opening it on right now. I'm just trying to, I'm thinking maybe he means in R rather than R studio. Doesn't it already mean?
You have to check out in our studio. So I think by default, I just checked something. Because if you wanted to use, if it were available, then you could do library read Excel. So you could enter. It would work. But it says error, there's no package. I don't think it went over. Okay. Okay. So everyone, read Excel is not available in our studio by default. So you need, there's this function in R called install that packages. Did you ever
No, but with RStudio that should have been loaded up.
It's not.
not for everyone.
If you had a new a fresh version, it should have.
I just installed this. I mean, the R studio.
Did it? Has anyone else tried that? So, and it says it can't install them.
Well, it's not with it. It doesn't. It's not.
It doesn't come with her version.
Oh, okay. So it doesn't auto install those. So what comes up when you do this?
There's no package called Read
Read.
You can just go to the tools. Yeah, that's what I was thinking.
Yeah. So if you don't have that, yeah, you can go to Tools, install out packages. I think ReadR might come package. Maybe ReadXL doesn't. Then you should be able to just write, if you say repository, you should be able to just write in the package name. So for example, ReadR. If you get that, don't worry about it.
Yes, after this is stuff right here. So now I'm going to do the library. Yeah, library.
For example, if you also want ReadXL.
Oh, you just
Read Excel.
yeah. Yeah, so now you're good.
Okay. So if you don't get anything back, it means that it's there.
If you don't see any red, then that means they're good. Thank you.
Yeah, sorry about that. I thought they had that prepackaged with, but I guess not.
Just highlight that, just copy that. Oh, no, copy the entire thing. I put it on that too. Yeah, so now you want to see. Yeah, I still work for him.
Yes. So Tools install out packages is one way you can install what you need. So if you go to Tools, install out packages, and the ReadXL package, that'll give you what you want.
Tools at the very top, and then the tools, and then this is a stop page. Yeah, and there's the name of it in that.
Okay. Let me double check it's
I
connecting.
just tried it.
It works or no?
It does work.
Okay.
So, so let's try the
It's a weird underscore. Or so, yeah, so let's say let's type.
So it's like you have to fix the oh yeah.
That's really strange. Do you have another web browser?
Yeah. So if you want to call once, you can change the name of what the object is you want, but you can leave it as once. It's okay. Yes. So just go to tools.
I don't know, that's what I was gonna now we just
It might be someone else's done it. Their email address is
So
Yes. You write down your email.
does this automatically bring in now that it's downloaded, do I need to now execute?
yes. So right now try with the drop down.
I'll just
And it should
okay.
reading CSV to file
I'll read it.
import CSV.
But it's not,
Or import data set.
it's not data.
Excel. Oh, so use the library to.
Did you talk about those?
Not yet, not yet. So we're still using the drop down because the drop down means we're using the code. Okay, so we say file import data set and then Excel. So
But the read Excel.
so read Excel is now installed.
Okay, that's my question. Now it's installed. It's in Excel. In app data. So you just put whatever they put.
So you have.
Oh, this is a.
Depends how they. Okay, so yeah, permissions are always
Okay. Okay, great. So you see this plus sign, so we the command is whatever.
It's the right, so part of it is this kind of jump. My job makes this trouble. So for maybe different.
So we want to read in
so for some reason it's
query. So what was running was that this server got also included, so we just want to
you're just
add an initial one. So when we read this in, it's gonna put everything to the screen, unfortunately. So we want to save it into an object. Because we want to put a variable in here. So like something equals, we want to call it an int somewhere.
Okay, so he's got.
so
Yeah, we can call it
that's loading the function. So
well, if it's saved on
Excel.
that should be it.
so first we need to load the package with the library option.
Yeah, no, I know, right?
I
So
think-
it's totally.
I don't know so much about it, but yeah, we want to make sure that the library is listed. Because it said could not find function we can call. Well, if it says there's no package, yeah. So this page is
So,
Usually it's not closed capital desktop.
yeah.
It's just like desktop, and you can,
So,
the same thing in our
So-
is, you know, that's the. Okay. It's gonna be all, like, possibly. So I hit tab.
so Dropbox is my text.
Like, that is really, really handy. Right, like, I read full voice. And now look at time again, so I wanna know.
Really quickly, we're just gonna do.
There we go, it's on. So I'm just gonna type that. And now I know that there are no heroes. Enter. And now I have this
Just,
text.
let me see if I do.
Oh, this looks like there's data on documents in the same, so that's. I think it was similar to that.
I'm not able to write it. Well, I can't, I'm not read it.
This should still work, it's just, it's.
Okay, yeah, I looked up how to do this in text.
Oh, did you get the same thing?
I got, no, yeah, first I had errors, it was the same user.
So I was trying to do the default data and I had to move the whole thing back here.
Yeah, so like, when you click this.
Oh, you have to write it, I have to write out the directory.
Oh, you did?
I read it out, yeah, it doesn't like it to work.
Oh, from where it was actually.
Yeah, I put like that, put tilde,
It's just.
slash, the name of my directory, and slash, and then monuments, I like, and all quotes. What I do is I get WD to get the directory, and then I just copy the path from there. I wouldn't, it's just,
I thought we just took in.
I put it in the default directory.
Right. I may not be able to default directory, but I thought I did.
I mean, that gives you, when you say get WD, that is the default, that shows you the default directory, and that's.
I got WD.
See, my name.
Oh.
Get WD and then open was.
Oh, and then put the name of.
No, don't put anything, just hit the
Oh.
return.
Gotcha.
Then it gives the default directory, and I'm in it, but I still had to write the path and put it in there.
I know, I'm in the, actually, right, I'm in the default directory too.
I can't write it.
And then she just gotta do like.
So for that, though, you just wanna copy that link and enter it and then it'll prompt you to download it. Yeah.
There is data frame. What's the code for right area? There's right underscore CS.
You successfully done so you've actually succeeded. Yeah, so you look at you're about to call it that. You want to call it that.
If you don't put the path, then it's out to your working directory.
Currently, it's called Onedimensional. So I can do that.
So have you done it where you copied the
Yeah, try that.
Yeah, I mean, so I think this is just doing. Install.
The only reason I think it worked is because it's the date modified change.
Oh, you did it on the drum.
I put in right CSV, I put monuments, and then the path is copied. Large copy. I don't understand much of this. You know, and although I was trying to write the file when we needed it. Like I was using the word this time, just for design and CSV. And because of that, I can make it like that. But why the heck do you change the name of your file?
Right.
Yeah, it's making me. But yeah, I have to write this. Yeah, of course, you know. The name has no, I put around the paths, but
There's a function called right underscore CSV. It's in this particular bundle. Bundle is not this. Oh, I get up. And so it's right on.
Yeah. Yeah.
This is all.
Okay. Okay. Yeah. Yeah. So another stuff change section. Yeah, so put your name in there and change the file.
So
I still don't understand why.
yeah, I got you.
I'm sorry, why it's not, oh, it's not reasonable to put the whole passage in? Boy, this is.
We'll just start with functions. ACL.
Yes. So. Okay, so just download the website directly, and then try to read it in using the browser. All right, so there's been some things. Okay, so I thought the Read Excel package was bundled with R, but or with RStudio, but I guess it's not. So readr seems to be, I believe. So install.packages is the function that we use to install things, but much more intuitive way. Starting out, you say tools, install packages. You said read Excel. So it's gonna read and download that, so what that'll do is it will grab that package off the internet and install it on your machine. So that's just like downloading a file, more or less. So if you want to use any of the functions that exist in that package, you have to use library. library. Okay, even though library is not a very intuitive term. So install really means download. Library means use. Use this package. Okay? So that's what we mean by invoke the read Excel package. So you have to install it. So there have been some people with some permissions issues on your machines with downloading packages. If that's the case, let me know, because if you do the install that packages and then you go to say library and it still says nothing's there, I'll try to help you fix the permissions in as much as I can, as long as you don't need an administrator. Yeah.
When I did the drop-down menu, it automatically had a library command for me.
If you so that'll be
Yeah, I didn't have to.
and if it's already installed, it'll tell you that if it's already installed, it might ask you to restart. So I don't know why that did that. It might be a new version of RStudio. But install that packages with the package name in quotes. So is the way you install packages. When you invoke it, though, when you actually call the functions up, you don't technically have to have quotes around it. So there's a reason for that. It's kind of highly technical. Don't worry about it. But most times when you do this with a function, R is going to look for an object with that name, right? It's going to look for a variable called readXL, a data set called readXL. In the specific case of library, it doesn't do that. It knows you're trying to call a package. You don't have to put quotes around it. Install that packages, you do. Yes.
Do you have to use the library command whenever you use any install package?
So let me explain the reason for this. Okay, so I have maybe let's say I have 400 right packages installed in R, and I'm running a script, and I don't want let's say I have a package that reads in map type data. I don't need that every time I run. I don't want those functions loaded every time I run R. So by default, R doesn't load any of the packages up. So you can think of this as kind of a load command. So normally for a script at the top, you load the packages and then run your commands. So, and the reason for that, if you work in Stata, for example, in your ADO folder, all the functions that you've ever downloaded are accessible. One of the big reasons for that is it assumes you have a much fewer set of those. And the other thing is, in R, if I write a package, let's say I don't like the read_CSV function in readR. Let's say I want to make my own read_CSV function. That's fine. I can make a package and I can put that to a place where you can download it. So now readR has a function called read_CSV. I have a function called read_CSV. So you only want to load the package with that has the function that you want. Does that make sense? So there are 100. You can think of some simple commands or something like that. That there are 5 or 6 packages that have the same function name. So there are ways to be explicit about that. We're not going to get into those. We're not going to run into those that much. Where you loaded 2 functions that have the same, 2 packages that have the same names. But that can happen. So this is how you install it. This is how you read it in. That's how you load up the functions. And so now, if you go to use any of those functions, they'll be available to you. So we do suggest to download the Excel and then read it in. You can, I believe, read it straight from the internet, but some people are having some odd problems with the an error with zip. But you should be able to use import dataset from Excel, paste it in there, update, and it should give you this. But if you're not getting this, if it's giving you some error when you go to click update, it won't do that for you. Just go to the website, download it, and just look. Just paste. So here, let's do this. So go to the website, download it, and then you say from Excel, and then you click browse, and you can go to wherever you have this stored. For example, monuments is here, and it should come up. But if you do get an error, if you're reading it off your hard drive, then definitely flag us down. That shouldn't happen. So something either went weird with the downloading or something like that. So now, right, we said See, so some people were getting this. Read underscore CSV zip file cannot be opened. I don't know why that was the case, but if you do it from the drop-down menu, there probably is some option on there. Ah, yeah, that's why. Because our studio is smart. It knows that the read Excel function cannot read the data straight off the internet. You need to actually download it first. It just gives you some very nice and convenient code that says, like, this is the URL. I'm going to download it for you, right? Download file, and then read it, right? So our studio does have some nice little wrappers that, you know, instead of going to the website, downloading it, saving it somewhere, opening it, this is the actual code. So no matter what folder you're in, it's going to download a file in there and then read it directly into R. So that I can just copy this code. Come on. And it'll do exactly what I want. And then you can add other fun things like file.remove. So that what this code will do is it'll go to this URL. Say, I want to download that URL into this mon.xlsx, read it into memory, delete it off my disk. Right, in one fell swoop. So, so the drop-down menu does allow for some nice things, allow you to do some nice things. But if you're using Excel, just download it to your disk. It's a good practice anyway, right? We're showing you that for somewhat of a convenience sake here, so that, you know, we didn't have necessarily problems. Say download it here, whatever, you can download it wherever you want. We are showing you some of these things for convenience sake, just reading straight off the website. That's not so great, because what happens when tomorrow I change that data set? You want it to be reproducible, so you usually want to download the data. Now, we do got it in memory. So mon, so now we want to write it out as a CSV, but again, the functions we were saying that we are condoning to use is write underscore CSV. We're going to put dat in there, path mon.csv. We execute that code, and you get a CSV of the monuments data so that you could just read it into anything that's CSV. So this lab is a very simple converting Excel to CSV kind of using R. Right? But again, that's not so exciting or interesting. But when you start doing data manipulations and merging and that kind of stuff, and then writing it out as a an analytic data set for someone else to use, that's where things get a lot more interesting, obviously. So the data IO key, give me one moment. I will put on the website. So, okay, so now I'll put that. So I'm just going to refresh my website. And if you just refresh, a few times to clear your cache, it should be in there, I believe. Yeah. There you go. So the key should be up there now, which essentially has the same exact things we were talking about. Again, library, the install packages, downloading. This is exactly the same type of code. Just the only thing here is it's downloading a file to a temporary directory. So when I close my RStudio, it'll go away. And then We showed two different ways, write.csv, which we're not going to necessarily talk about, but write_CSV using readr. But I'm going to show you the output of both of those because it is important because they're not exactly the same based on defaults. So I'm just going to library things in. Again, it's going to download the file. It's going to read the data in. And I'm going to write two things out. And I'm going to show you the output from write.csv and write_CSV. Okay. Come on. Okay, just gotta. Okay. The one on the left is write_CSV. The one on the right is write.csv. The big difference between the two is the first column. First column is just the names. First column here, write.csv assumes you want to write out the row names. And in this case, the row names are just 1 to the number of rows. A lot of times you don't want to do that. Really, many times you do not want actual data to be contained in the row names. Okay? But the defaults in write.csv say, hey, we assume your row names are important to you, so we're going to write them out. And a lot of times that's not what you want. Write_CSV doesn't assume that by default, and it doesn't print them out. So, although they are faster, they do have different defaults, different behavior. We are going to go with the one on the left and assume you don't care about the names of the rows. If you do care about the names of the rows, make it a new column. All right. So we covered a lot and at a kind of breakneck pace at times. So one thing I like to talk about in this class a lot is a language. If we were taking a foreign language, a spoken foreign language, I would not assume that I would be fluent in that language by the end of a 3.5-hour period. So I don't think you should assume by the end of a 3.5-hour period, you should be able to write R fluently. But you should be able to get some of the gists. So we talked about data input, output. So we did show you how to do drop downs, which in the long term, we're not necessarily going to condone. We still think everything should be in code in sort of a script. But starting out, it's a really great way to start out because it gives you the code. And you can copy and paste that into wherever you want. So now, what we've covered so far is kind of data types, very simple ones, numeric and character, kind of how to differentiate them, very simple algebraic operations, how to read a data set in, how to write a data set out, kind of the basics of our studio, right? How to do some things there. We'll talk about, so maybe right now, in about 10 minutes, I'll talk about projects because we did talk about working directories a lot and it's kind of, why are you talking about this? But keeping things kind of organized is really important for project management. It's also, it makes your life a lot easier with code. So, the way you get a project is you say File, New Project. I'm not saving the key. So, don't worry about this one. Sometimes you have an existing directory. Sometimes you have a new directory. Either one. I'm going to start a new one. So it gives you 3 different templates. If you wanted to design, if you had a bunch of functions, you wanted to design your own package, or if you create one of these Shiny applications, which I'll show you a little bit a gallery in about after we go through this. Usually, though, you want to start with an empty project, create a name. I'm going to put this on my desktop. Best analysis, right? So you can do this thing called create a Git repository. It might give you these options or not. We're not going to talk about Git. Git is a version control system that if you had like code and you made a lot of changes over time, it can track those really well. But that's a whole different thing on its own. So we're just going to say, okay. And you click create project. So what it'll do is it'll close whatever is going on in your studio, restart it, and then go into that directory. And you'll see in the top right-hand corner, you are in a different project. So if I make a file new file, let's say in our script, say read CSV, like I'm going to say library, readr, And so I'm going to currently, really quickly, I'm going to copy that monuments data set to this test folder, or this best analysis folder. Nope. So I read it in, right? I'm going to save this as read function. Okay? Got this. You click over here. You can click new project, open a different project. Right now I'm just going to close the project, and I'm going to open it back up, double-clicking this project folder thing. So I'm going to close it out, and it'll go back to whatever I was doing before in our studio. Okay, so I'm just in no project. I'm going to close out of this. So it's hard to see, but there's a .rproj file. So if you follow the steps here, it'll make a project. So when you double-click this, it again automatically goes to that directory. You're in that project. It'll open up whatever scripts you're going to open up at that time. And again, because you're in that directory, you know that the monuments folder is in there. So you can bundle up this file or this project more or less. Sorry, and give it to someone else, and they should be able to run all the code. So that's something. That's like, for example, how you might use RStudio projects to do some project management. That being said, we're going to talk about this later, but I always like showing this stuff on the first day because I think it's some of the coolest stuff. So you go new file, R Markdown. So we're going to keep a document. There are other things. I'm going to say title, example analysis. And I'm going to keep it as the default to be HTML. And I'm going to click this button knit. It's going to make me save. So example analysis.rmd. RMD stands for R Markdown. And so when you knit it, let me pull this over here. You have code over here. That's like, this is some R code. This is some text. Saying this is an R Markdown document. We're doing a summary of a data set. It does a plot. And on the output, it gives us the text. Make this big. It gives us the code, the output. So this is, I guess, the most analogous thing to a log in Stata, but it's a little bit more, it's better because now you can include plots, right? The code for the plot was in there, and we didn't want to print it out, so we could say print it out or not. It'll embed this thing, and if we go into that folder, and look at example analysis, there's an HTML file. And the beauty about this is you don't just have to knit to HTML. You can knit to a PDF document or a Word document. So if you knit to a Word document, what's going to happen? It's going to run that code, get the output, collect it, and then open up a Word document with things embedded once my Word pops up. So now you have a document. Again, it's got a name. It's got, let's make this bigger. It's got an embedded plot. It's not formatted exactly the way you need it to be all the time. There are ways to make it super formatted, but for the most part, for an example analysis, you want to send to somebody, they can throw track changes on there, right? You can move forward with that. But then PDFs also, especially if you like writing, if you have to like write an equation, it'll convert it to like a Microsoft equation editor thing, but you have to write it in a specific way. But if you knit it to PDF, it'll apparently fail. No. It'll usually work a lot of times. I updated my operating system like 2 days ago, which is nothing you should do before you teach a class. But I need to download this thing called LaTeX, which will allow me to convert things to PDF. But Word and HTML should more or less work out of the box. Yeah, so that's the fun things. That was projects. Oh, Shiny. So we're not going to cover this really at all, but if you start getting into writing R, this thing called Shiny allows you to do some fun interactive visualization. So let's do, where's the simple ones? There. So here, it's pretty simple. It's got some drop-down menus, X variable, Y variable, cluster counts. Here's the code that goes into that. There's a server file and a user interface file that pretty much specify like, hey,
I want a drop-down menu for the X variable, a drop-down menu for the Y variable. I want you to be able to specify the number of clusters, and I want you to put a plot in there. And this is all R code, and the server is where all the R code is executed. So pretty much you write some of these things. It is a totally different syntax. I will give you that. But the nice thing is you start clicking here. I want it to be pedal width. So sepal length is my X variable. The Y variable is pedal width. Let's see. How about species? Nope, that's a bad one. Pedal length. And I want to say there's 3 clusters. Actually, I think there's 4 clusters. You know, what if I ran a clustering method but there was 5 clusters? How would that kind of break down? And so all this is written in R. It's interactive, and you can kind of specify some really effective yet simple kind of inputs and outputs. Granted, I understand this is if day one of learning a language, this would be writing in a specific dialect of some region or something like that. But with time, all the thing I want to push, this all is written in R code, right? So the 2 things that I think are really important, Shiny, but that's less common to be used, I think, for new users. But R Markdown is really, really effective for having your code and your code and your output in one area. So the nice things here that I didn't demonstrate. So we did a summary of cars. It was like input, output of cars. So cars is a data set. That's a toy data set in R. So cars and so we'll talk about how to subset data. But if you want to say like the mean speed of the cars is miles per hour. And again, this shouldn't make that too much sense to you yet, but I want to demonstrate you can then write things. Oh, we got a PDF, I think. Yeah, so let me go to Word. So the thing I want to demonstrate is that you can then say like things like this, where you say the mean speed of the cars is 15.4 miles an hour. Where I didn't write in 15.4, that was executed in the R code. It grabbed this column, got the mean, and embedded it in there. So that you can actually write a full report, it's really hard to do this, I will say. But you can write a full manuscript where you updated the data and rerun everything, and all the numbers will change. So if you do data management, reproducible reports, or consistent reports, this is really a big deal, I will say. We will touch on that around the last day. We are going to get you up on R, but usually I want to do some of this stuff to excite you because I think it's really cool. And at the end of the day, it is a totally different. There's some weird stuff going on here, but at its core, it's just you say, I'm writing text. I may be writing in a way that says, I want this to be big text. I want it to be a header. And then you're also doing some other things to say, I want to embed some outputs from R. And you can have it all kind of bundled in one and get it that Word or PDF or HTML. But for right now, right, we're still just reading data in, writing data in, and tomorrow we're going to be talking about some subsetting, manipulation, actually working with the data. All right, so I'm going to email tonight who is taking the course for credit so that you know. Yes. I'm just going to email so that you know, and just email me the badges. I believe I will email tonight when the homeworks are due, but more or less, usually I think homework 1 is so homework 0 was the try-R. You can give me that at any point during the week, but homework 1 will be due I think in 2 days, so probably Wednesday, and really only due. I say due because we're going to go over the key. We just want you to submit the homework before the keys are released. Yeah. So your question?
No, I just didn't need your email before, so.
Yes. Yes, that would be good. So did everyone else get the emails? Okay. No. Okay. So you two really quickly. Okay.
I'm not taking it for credit, so it's less.
Okay, yeah. But I just want to make sure you're in there so that, course evals and all that kind of stuff. So if you 3 can talk to me real quick. All right, last minute. Anything, all this stuff will be up there. If you go through some of the subsetting data, data summarization. If you look through anything and you have any questions, don't hesitate to email me.
I've been having trouble while reading, right, using the default directory, I'm in the default directory, I look at it, it says it, but if I don't put the whole path in, like in the get, in the read CSV, and it doesn't work.
Okay, let me see. Thank you. So did you put your, was that your JHU? JHU? Can you put your JH? Okay, no. So that's where we insist.
Yes, right.
Okay. No. No, that's fine. I just want to be able to. That's fine. I just need to talk So again, so you install Read Excel. But Read Excel and Read Excel. So let's try to install Read. Yes. So tools, install it back. Can you just mark which and put your emails out on there? Yes, I'll email Aisha to figure it out. Who's in the past that is yeah, but if you have any questions, email me. I'll email you. So if you go to homework 0, try R. Just go through this monitor. It shouldn't take you that long, especially after today. It's just like kind of going through the class. So you just you get a badge, like a badge, and just a screenshot of it. Okay. Still. Oh yes. That's the directory.
So what you're gonna do, I'm gonna do a new project.
Yeah.
So we actually have to make sure.
There you go.
Well, we can change
Data IO lab.
and you can change all of them.
Sure. Or just you say just those files.
Well, I mean, also so basically double.
I wrote this. So this is, so what you're doing here is not that. So this is finding a new file. So if you click that,
Yeah.
first comment. Yep.
But let's ask them. Yeah.
Sorry, at the very end, you need to type monuments.
But the thing is, I want to get sure if mine were
So this.
I didn't make an error, but. Well,
Documents.
change from Excel to CSV.
So sorry, go back to the here.
It was down here in my file.
So
This is the project.
That's your document.
So that's where.
Makes sense?
Um,
Yeah.
So, I think we can.
No, no, no.
This is.
Yeah.
I was just. Sometimes the graphic pieces, there are some strange things that are required, but in reality, it's just the first. I don't want to just get everyone to.
Do the same thing in terms of.
Yeah. So in general, like my application, it's kind of hard to like years long path. So
This
you
one
guys
seems
want
a
to
little
essentially
more.
navigate using session to, you would want to navigate those things that you want to set.
in my,
Yeah.
And then you're going to navigate to the first. Yeah, so if you do that, then it says here, it's like working directly to this like log path that you ended up having here. And now, if you wanted to do this again.
So maybe might be so should I try to
But that's this is just about there. If you're working within this whole.
yeah.
So then, we can save this.
Yeah, so when this one is text file, you see that it's red and then it has a star. That means obviously you can use it. Okay, that's here. Yeah. And then you do save. Black. Means that all the changes are now saved. So this is just a file.
Okay.
So you can open this back up and like click through reference this command, change it, if the file changes.
So.
wait,
So we have additional questions.
You can, I want to hear is asking us to do
Someone I know. Thank you.
I didn't look at the request, but I saw the show. So we have a project in common, right? And so I created a new project.
This is not too long.
In my,
Yeah.
so that opens up our studio. And then, is that all?
Hmm.
And how it, so like you guys are working on this tool here. And that just pulls up what you guys are working on, but like, I wanna know how we like save, I want, like, how do you, like, we're save, like, how do we save it and make sure it's all there? Is it just does, and, like, do people not really export? Case sets? Yeah. So say that we save out a copy of data.
This is a line.
Really don't really save out a copy, I mean, you can write it to CSV to send it to someone, but, like, you just save all of your code here and then you just execute it each time you open it, or?
Yeah, so that's one approach.
So it might
Because
be,
the things that you need in order to
Yeah, I was like, can try to enter
for your data is you need
the training.
the raw data, so a CSV file, an Excel file, and then the code that's used to read it into our local file.
Oh, I mean, it's something I can.
So all that's just
So if we say like.
in these .r files and in the original CSV files.
So this R file contains the .r files, where they are. And they're here.
I'm just gonna.
These are the .r files that are here. So what is the project?
I'm actually
Yeah.
Like, so if I were to, because we're working on a project, like, what I just sent him my .r file and the raw files, and that would be it.
Yeah, that would work. I'm not sure if it would suffice to just send the project files.
No, you have to send the whole folder, whole folder.
But what you said first,
Yeah.
if you send the .r file and the money, then that would completely suffice. Like, I'm not sure if the project file is or it's just some sort of.
It's not like
I
format.
don't use one project or CBS. I just, so what is this?
So if I close this,
No.
How are we sending those over?
and I just want to get back to, so here, here are back to my file. So I would just work here
So we
now.
need to
Save.
move on.
That's how save. That would be it.
This is 2015.
So let's try to make it sense.
I will look down on it where we do tomorrow.
No, you have to give the whole folder. It's not, what's it called, the R project folder is not sufficient.
Okay, so what is the purpose of the organization?
So that allows you to double click it and open up the R project folder in our studio. Right?
It's kind of
It's like an extension.
configuration to, have all the things open that you want.
So I don't know what's going on with
So
that.
instead of just
I
opening
think it might be an Excel thing,
It's like, if
but I
you
don't know
start
what
in our
happened.
studio, there's nothing open in the archive, and no wording.
Yeah,
Sorry about
It's
that.
a training thing that we report back.
Well, it's because it's the default. It's because the way it reads is.
This is the configuration for this project.
Yeah.
Okay. So it's useful.
It is useful, yeah.
Do people not save down copies of their data set, or they just open it here and it's just already there?
So there's a way for you to save like a deep data analysis version of the DTA file.
Yeah.
There's like
That is
format.
right,
Well, no, there's like, because you could have a ton of stuff in the environment. Like you could have, your x equals 26, your y equals 2, 7.
Okay.
There's like a way to save all those objects
I don't know. It seems like Excel.
in R.
So I don't know. It's something
And
like
that's kind
configuration.
of
That's a
needed
little
when
strange.
you have like,
We'll talk about a way to
you
at
got
least
a
make sure it's in Excel.
and like have these labeling sheets.
Like 50 pages of data integration, yeah, because it was in, there was some data.
All right.
So that would be all,
5 minutes.
that would be all here.
Yes, and I can do, let's say it took, so like good examples would be like hydrogen movements, in which like you don't necessarily work with your data. There are different things that you might want to combine. You might work with.
So
Um,
the idea
that
is,
can be an object. And if that DNA string is really complex, then you might not want to, read it every time. You might
So,
want to save
it's
it
a training grant, and
like as
I
an
have
object,
statistician.
load it as an object. That's another way to sort of.
Software analysis, machine builder.
So it's data, you're always out, there's no merge.
You can merge still. You can have,
And he suggested that
So who's
But
building
it's a joint, but you don't,
the
you can't save that down.
statistical mentor suggested that I learn R.
Okay,
So
okay.
you're
you
building.
can do anything you want.
Yeah.
I think that what we're
Yes,
struggling
yeah.
with is that we're
Okay.
gonna go.
Well, my concern is, if,
And
because it's time management,
That's how I was.
if I struggle with
Like,
building
additional
R,
credits, like how we're gonna.
how do I assess maybe I can't use my
If you have like
No, no, but I'm trying to figure out to what level, how hard is
that is like data cleaning.
R
So then we are having the bus to ride.
We go outside and
If
say-
it's one data set, and the biggest thing is data cleaning, right? So I mean,
And that's like,
one
okay,
PhD, our PhD is
is clean. In the sense there's like not a lot of missing data, very little things aren't weird, which everything. It's a relatively, relatively straightforward thing, but
There's no
learning the art rate to do the data thing, I don't know if the most important because once the data is clean, the models are relatively straightforward.
We're doing data cleaning now. So when we get to the second phase of it is going to use in building machine learning. So I guess I'm trying to figure out in your experience in doing civil type work, how long is that?
With respect to the code or like with respect to machine, like building machine learning? The second thing can be, okay, building machine learning algorithms.
Do you think we're gonna switch?
So like implementing running an analysis is relatively, there's a lot of factors. Like,
What it's gonna
no
help
one
is
wants
like
to use and then it's really good, like that can take a while. But running them, like whether data machine
Like all of our
learning,
figures are on ours. All of those.
once you get the size, probably like if you have the data, reading it, doing something, and then with the model, there's not too much of an overhead. Like doing it wrong, doing it right. It's hard.
So going forward, all the time data.
Database and what's saving and what relational.
So yeah, the college on Python. I mean, the fact that ours are 10,000 packages, it's probably tomorrow.
What's yours is Hawaii are.
Is at least tomorrow, but I don't heard that except Python. But with machine learning, like scikit-learn, so definitely a couple more state of the art. But more like for academics, it's kind of a toss-up. But I would say more R just because like I would suggest R if you're doing this stuff.
What's the pricing? What are they?
Skill tree. Sorry. So, yeah, okay. Thank you.
I have no idea.